Good evening. Guys, I don't know if my network today doesn't seem good at all. Can I just get an indication? Comment section. How is the network? Are you guys hearing me well? Am I audible? Is there no glitching? Is there no lag? Is the network fine? Okay. Royal FX Markets says it's good. Okay. Well, if it's good, then I'm happy, because I'm starting to be a bit worried that it may not be as crisp and as clear as I would want it to be. Yeah, because I don't know. I think it's just at the beginning there, it just seemed like there was a bit of interference. Okay. Well, since we're all well and good, I'm happy that we are. Hope you guys had a good day. That you had a reasonably great, good day. I hope so. All right. All right, so let us see if we can't leave the realm of what we were doing yesterday and just see if we can't. I just want to look at a few other possible solve for X type questions. Then thank you so much, Killer B, for the rose from the get-go. Nothing much has started, but appreciate the gift. Yeah, we'll look at some solve for X type questions, just like of a different flavor from what we've been doing, just so that we can see that that people are seeing what they ought to see. So we'll do that. We'll do a few nature of roots type questions, because sometimes those do sneak into question one. I think are worth looking at. We'll look at some nature of roots, and then that is actually also clear. Yeah. Sorry for the delay. Just need to get my bearings right. Once they're right, then we can get kicking, get flowing, if you know what I mean. I hope you guys have had a good day, like I said, and that you're ready for another segment of other examples where we're solving for just a bit more, requiring a little bit more from us. Okay, so I'm gonna do two examples. First one, you can see here we have 2 plus 2 over 2x, 2 over 2 plus 2 over x minus 1. So far, actually, let me just change this 2 to an x. Yeah, so that this question has a bit more power and flow. So guys, for those who are joining in for the first time, we are doing a grade 12 build up to the trial exams. Okay, grade 12 build up to the trial exams. So we are doing questions that are related to the first question in the exam paper for paper 1. I just need to get an indication that once again my network is fine, because like I said, my network, I don't know, just from where I'm standing, it seems to exhibit a bit of instability. So I need to be clear with my audience, or I need to just get a sense that please just at every turn let me know if it's fine, if everything is fine. So we're doing a build-up. Like I said, we've done a few questions in previous lives. Yeah, that's what I thought, Mon. That's what I thought. I did think it's a bit unstable. It's doing funky stuff today. It's almost as if like it's fighting with everything that it possesses against whatever is happening today. So it's a pain. It's a pain. It's a pain. But it's fine. Let me just see if I can't change it up a bit here. So that's what will happen. Okay, I seem to have a bit of stability when I have it on here. So it seems like it wants me to actually switch to this side. It says good connection from my side. So I think we can now fly. Alright, so we have x plus 2 over x minus 1 is equal to 4. Hey, you see, this network. You see, this network today. Our network is fighting today, guys. X plus 2 over x minus 1 is equal to 4. We are asked here to do what? To solve for x. So, the only problem we have here is that we have a fraction. And in the fraction that we have, the denominator, where we have a variable in the denominator. Okay, so the expression we have in the denominator is x minus 1. All right, so in order to solve this equation, we need to first make sure that we get rid of the denominator. And the way that we do that is by first and foremost looking at the denominator, factorizing it if possible. All right, and I just want to write those steps down here. Okay, we would look at the denominator and then we would factorize the denominator if possible. But in this particular situation, we can see that the denominator is as simplified as can be, so we cannot factorize it. Okay, but that's what we normally do whenever we have a fraction equation and there's a variable. And by variable, guys, I mean a letter of the alphabet in the denominator, the letter of the alphabet that we're trying to solve. If there is one, then we make sure that we first look at the denominator and see if we can't what? Factorize if possible. If not, then step number 2 is that we need to find the LCD. Now, for those who don't know, LCD is just an acronym that means lowest common denominator. So if you come here, guys, x minus 1 is the only denominator with a variable that we have. X has an unseen denominator, which is 1, and 4 has an unseen denominator, which is 1. So to find the LCD, we are going to have to write down the LCD, which in this case and situation is x minus 1. 3. We need to then write down our restrictions. Write down our restrictions. Now you're going to be asking me, what do I mean by a restriction? Listen, guys. If you look at this fraction, right, there is a value of x which would make this fraction undefined. We substitute the value of x, would first and foremost make this denominator 0, And we know that when we divide a number by 0 is undefined. All right. So we want to look for that value of x which would make the denominator of this fraction be 0. All right. And so we know that the value of x that we could substitute here in the denominator, which would make this fraction 0, is 1. If we substituted 1 in the place of x, minus 1 would lead us, or lead the denominator to becoming what? 0. Okay, so is really not kind today. All right, it's not kind. Okay, but I hope you guys understand that, as I had said earlier, that if we look at this equation, first and foremost, we check the denominator. And if the denominator, we are able to factorize it, we go ahead and we factorize the denominator if possible. But if not, then the next step would be to find what we call the what? The lowest common denominator. And here we can see that the only denominator that is there for this equation is x minus 1. So our LCD is x minus 1. Step number 3, okay, is that we want to write down the restriction. Okay, thank you in the comment section, and I'm glad you guys picked up that error. All right, when we write down the restriction, of course, what value of x, if we substitute in the denominator, would make this entire denominator be 0? We know that that value of x that we would substitute would be positive 1. So we know then that x cannot be positive 1. Okay, x cannot be what? Positive 1. That is our restriction. Then step number 4, we multiply each term in the equation by the LCD. We multiply each term in the equation by the LCD. And when I say we multiply each term in the equation by the LCD, we multiply that LCD in the numerator of the equation. All right. So what I'm going to do is that x is my first term. What I'm going to do is I'm going to multiply x by the LCD, which I know the LCD is what? X minus 1. So I multiply this x by x minus 1 plus, that's my first term, I've multiplied it. 2, I multiply by x minus 1. But I'm sure you remember that there was already an x minus 1 in the denominator, so that's fine. I multiply the 4 by x minus 1 as well. Okay, what does that then do for me? It does the following. This x minus 1 and this x minus 1, you divide the x minus 1 by itself, we are left with 1 and 1, because x minus 1 divided by x minus 1 is equal to 1. Okay, and then of course what's left over? We are left with x into x minus 1 plus 2 times 1, which is equal to 4 into x minus 1. Now we no longer have the denominator, which is great, because now this affords us the opportunity to then be able to do what? To expand, simplify, and get our standard form. Expand, simplify, add and subtract like terms, that means, and then we attain our standard form. So let's see. What's x times x? We get x squared. X times negative 1, we get negative x. 2 times 1 is 2, equal to 4 times x is 4x. 4 times negative 1 gives us negative 4. Okay, and then now what do? We transpose so that we can add and subtract the like terms and get our standard form. So x squared minus x, we then transpose the 4x, we get negative 4x plus 2, we transpose the negative 4, positive 4, and then obviously the like terms there are x squared minus 5x plus 6, which is equal to what? To 0. Okay. Then at this stage, what can we do? We can go ahead, because we have our standard form, we can factorize. And I'm hoping all of you at this stage are like, well, we are in familiar territory, so there is no problem with that, sir. Factorization is not a pain at all. Our factors of 6, we know that we have to have same signs in our bracket. According to what? According to the sign of the middle term. So that means we're going to have a negative and a negative. The factors of 6, if we multiply, we get 6. We add, we get negative 5. We know that is 3 and 2. Not 6 and 1, but 3 and 2. That works, because negative 3 times negative 2 does give us positive 6, and negative 3 minus 2 gives us negative 5. So that works out nicely. Then let's not forget the x and the x equated to 0. We can now apply the 0 factor law, which then means that x minus 3 is equal to 0, or x minus 2 is equal to 0. That is the 0 factor law. We then can write the independent roots of our equations that are linear. So x is equal to 3, or x is equal to positive 2. Okay. So step number 6 was that after expanding, simplifying, and getting our standard form, we factorize, failing which you can always use the quadratic formula, hence QF. 7, we then apply the 0 factor law. 8, we get our roots. Then 9, we check against the restriction if all roots are valid. We check against the restriction if roots, in other words the solutions, are what? Are valid. Okay, so if you look at these values of x is equal to 3 and x is equal to 2. Remember that we said our restriction is that x cannot be positive 1. Why did we say x cannot be positive 1? It is because in our denominator we could clearly see that if the value of x in any way becomes 1, that means 1 minus 1 is 0 in our denominator. We cannot have that. Why? Because division by 0 would imply that our equation is undefined, because the fraction is undefined. Division by 0 in numbers is not allowed because it leads to things being undefined. So we need to avoid that. Hence, when we've written our LCD, we write our restriction. And then our restriction, when we look at our final answer, we go back and check, does the final answer flow and stand true and does not fight against the restriction? And as you can see, guys, x is equal to 3 and x is equal to 2 does not in any way resemble our restriction. If there was an x is equal to 1 here, we would have to actually negate, or we would have to invalidate that particular root. But in this situation, all roots are accepted, all roots are okay, and all roots actually qualify to justify our answer. So that's one example I wanted to do. I'm going to do a second one, okay, so that you guys can actually more fully appreciate, like I said, these fraction type equations, and I wrote the steps here for the purpose of you understanding that for these types of questions, when you have fraction equations, you have to look at the denominator of each term and see, is factorization possible? If it is, you factorize. 2, you then find your LCD. 3, you write down your restrictions. Very important to write down your restrictions. 4, you multiply each term in the equation by the LCD. 5, you expand, simplify so that you can get your standard form equation. 6, you then factorize, or alternatively, you can apply the quadratic formula. 7, apply the zero factor law. 8, write down your roots. 9, check against the restriction if the roots are what? Are valid. And these are very important steps in being able to do these kinds of problems. I'm going to do one more problem so that we can better appreciate these sorts of problems. So I'm just going to turn over the page and then let's look at another question. 2x minus 5. This one a little bit more meaty, you know. One more. Minus 1 over 4 minus x is equal to 7 over x squared minus x minus 12. Okay, so once again, a second example where we have a fraction equation where there's obviously expressions in the denominator with variables in them. So if we revert back to the steps that I've indicated to you we can follow in order to solve these sort of problems, this kind of gives us a guideline so that we know how to approach a question that is of that nature when we come across it. So the first thing is to look at the denominator of the fractions that we have for each term and factorize the denominator if possible. Then find the LCD. So let's come here and check. If we look at the first fraction, we have 2x minus 5. It's over x plus 3. Is x plus 3 something that we must factorize? Should we factorize it? X plus 3, is it factorizable? Okay, so I'm sure you can see that x plus 3 is as simplified and factorized as possible. So we move on then to our second term, which is 1 over 4 minus x. Now, if you look at 4 minus x, there is a bit of a issue that one might take with 4 minus x, something that we have seen and looked at before in previous questions when we were solving for x in certain equations, even with inequalities, when there's two brackets opened and we see that our terms are basically, the order is not as what we would want it to be. The constant term is first, followed by the variable of x with a negative coefficient. I'm sure you guys can remember that there is a certain procedure of factorization we apply to ensure that the x value comes first and the constant term follows. Do you guys still remember the procedure? I even acronymed the procedure for us, you know, in the lives that we have done, I think probably 2 lives ago. Okay, what would we do here? We would apply what I call SCR, sort of like CPR when you want to resuscitate an individual that is basically gasping for air and basically cannot breathe properly, probably no oxygen flowing within the system. So we call it SCR because we see a disorder here that the x term, which is negative, and the constant term is before the x term. So what we do is we apply what we call S means sign, C means change, and R means rule. We apply the sign change rule. Okay, it's a form of what I would call factorization. It ensures that the order of the terms is what we would want it to be, especially if there's a negative x term. Okay, so if we rewrite then the equation, and I'm just going to practically do this. This negative sign is still intact. We have 1 over this 4 minus x. What we do is we swap around the x and the 4. And then what we do is we take out a negative sign. Now, please take note what this does to our expression in the denominator. We took out a negative sign, right, guys? If you take the negative sign back, negative times x, doesn't it give you back the negative x? Yes, it does. What about negative times negative 4? Don't we get a positive 4 back? Yes, we do. So therefore, taking out the negative sign is just simply a procedure we perform called the sign change rule, and it allows us to factorize this expression so that we have the correct order, the variable followed by the constant term. And we do this all the time whenever the two terms are separated by a negative sign and the second term is our variable. Sign change rule works like a charm every time. So now the situation you are finding yourself in is that you have two negative signs that are following each other, and these two negative signs have a relationship of multiplication, and negative times another negative. We are going to resolve that sign and get one actual sign so that we proceed with the problem with no two signs following each other, because if we have that, it does present a problem. So that is a form of factorization that we apply to the binomial terms in the denominator. Let's go to the last term on the other side of the equal sign. The denominator there, can we factorize the denominator of x squared minus x minus 12? Is it factorizable? Siamtanda says yes indeed. I agree wholeheartedly. So let's go ahead and factorize then. Okay, opening two brackets as we usually do. The factors of 12. This time round, our sign of the constant term is negative. That means that the brackets will have different signs. Minus for your constant terms means we have different signs in the bracket. And this minus sign says the highest factor of the factors will have a negative sign. So if we think about the factors of 12, we have 6 and 2, we have 4 and 3, we have 12 and 1. Which one helps us to be able to get this combination intact? Because remember, the negative sign means we have different signs. So there's a negative and a positive sign that should be there. And we said that the highest factor should have a negative sign. So which factors do we choose? 12 and 1, 6 and 2, 4 and 3. So I'm sure you guys can see clearly that 4 and 3 qualify the best. Then we just slot in the x and the x, and that basically means we are good to go and proceed to the next step. So if I now complete step number 1 of the steps towards solving this question, having factorized all I could in the denominator, now resolving and wanting to resolve the signs here, I'm going to have a positive 1 over x minus 4, which is equal to 7 over x minus 4 into x plus 3. Guys, my factorization mission is now complete. That means step number 1 has been successfully done and dusted. Step number 2, after factorizing the denominator, what do I do next? What happens next after factorizing the denominator? I need to then find what, guys? Tabolebus was saying it very nicely in the comment section. We need to now discover what the lowest common denominator is. All right. And lowest common denominator simply means this, guys. It simply means that I am going to identify in the denominator the common brackets. Okay, the common bracket that has the highest exponent. I repeat, the common bracket that has the highest exponent. Okay, so if I look at x plus 3, okay, x plus 3 is common for 2 of my fractions. And since it is common for 2 of my fractions, I see that this x plus 3 has the exponent 1. This x plus 3 also has the exponent 1. So that means for my LCD, I am going to identify x plus 3 as one of my lowest common denominators. If we take a look again in this particular fraction equation, I can also see that x minus 4 is common, okay, for 2 different fractions. And as it is common, we can also see that the exponent, this is x minus 4 to the power 1. This is also x minus 4 to the power 1. It is common as x plus 4. So I write the x minus 4, as a product together with x plus 3. This here is my lowest common denominator. X plus 3 into x minus 4. All right. So that's how I was able to identify the LCD. Then what follows? I need to write down my restriction. Okay. The values of x that x cannot be, because if x is that particular value, it would mean that my denominator will be 0. So for this bracket, x cannot be what? I'm sure you guys can see. What value would I substitute here which would make this bracket 0? Okay, what value? So x cannot be what here? -3. All songs is just answered in the comment section. And then for this bracket, what value of x can x not be, because it would make this denominator 0? Okay, so I want to avoid the value of 4. So 2 restrictions. X cannot be. And guys, when you have your LCD properly written, okay, you would actually find that, oh, this LCD that I write, my restriction is written from the LCD. Because for this first bracket, which value of x will make this bracket 0? It's when x is equal to -3. So x cannot be -3. Or what? If you look at this bracket, what would make that bracket 0? This one. It's when x is not 4. Okay? All right? I hope you understand that. So we write our LCD, and please guys, write down your restriction immediately after writing down your LCD. Please, please, please. It is a step that many learners tend to omit, and when they do, it leads to them not being able to actually write down the correct answer at the end, okay, because they have nothing to check against. All right, so please write down your restriction immediately after your lowest common denominator. Next step, after writing our restriction, we can now multiply each term, this term, this term, this term, by the what? By the LCD. Okay, and when we do so, that should lead to a cancellation of the denominators, so that we do not have fractions anymore. So I want us now to just use all of these next to all of, because it would be long. But I want you to recognize that if I took this x plus 3 into x minus 4 and I multiplied it here at the top, which bracket would disappear because it would cancel with x plus 3? It would be this x plus 3, right? Okay, so this x plus 3 would cancel with this x plus 3. Are you with me? And then what would be left over? X minus 4. So that would mean 2x plus 5 will be multiplied with x minus 4, because the x plus 3 would cancel this x plus 3. Okay, I hope you guys are with me and you understand what I am saying here. Because we multiply each term by the LCD, x plus 3 and x plus 3 would cancel, but x minus 4 gets left behind to be multiplied with 2x plus 5. Okay, all right. I think now, for the benefit of those that say they don't understand, remember, what did I say? I said we multiply each term by the LCD. So I'm doing this for those that don't really get it. I found the LCD. So now I multiply this fraction in the numerator by the LCD. But then what do you see? This x plus 3 and this x plus 3 will cancel each other, because this x plus 3 is in the numerator, this x plus 3 is in the denominator. Something divided by itself gives us what? 1. Are you with me, guys? So that's why then what gets left behind? 2x plus 5 multiplied with who? x minus 4. There it is. I've just written down here in this step what is left behind. Then we proceed. We do the same thing here. We take the LCD that we identified, we multiply by it in the numerator. Who's going to get cancelled? If I take this LCD x plus 3 into x minus 4 and I multiply here at the top, who gets cancelled out? Who gets left behind? You know, unfortunately, it's like life. Some people get cancelled out, some people get left behind. It's like in your life, you'll have a group of people that you know, but at the end of the day, some will get cancelled out, some will get left behind. Okay, so Samantha, you are right. X minus 4 will be the one that gets cancelled out. Then who gets left behind? It means x plus 3 is going to get left behind. So I'm going to say 1 into x plus 3. That's who got left behind, because the x minus 4 cancelled x minus 4. Are you with me? Okay, equal. Okay, now we do the same thing here. We're going to multiply by the LCD. All right, I want you to understand. All right, I'm doing this like off the top of my head, but we are practically taking this x plus 3 into x minus 4. All right, and you are multiplying by the LCD. Who gets cancelled out, guys? Now I'm sure you can see that both get cancelled out. So who gets left behind? Just 7. And this was what happens. Sometimes this is exactly what happens. The very things that you think you are going to take with you, you know, they get cancelled out by other things, and sometimes you get left behind alone. You are the only one that's pushing, you know. Sometimes some things get left behind. Sometimes it's like another thing that you didn't anticipate gets left behind. All right, yeah, and it takes wise people to realize that, oh, okay, maybe that thing, it just wasn't. Some people are there for a season. Some people are there permanently in our lives, so we just need to accept it when it is the case. All right, so this is just, sorry man, just a lesson in there, because you know, it's nice when we do these things. LCD, we multiply each term by the LCD, and that basically is multiplication in the numerator, but that is supposed to do what? Eliminate. All of this is helping us to eliminate the denominator, so we have a simplistic equation that we can solve. Now we are here, guys. Now we are here. I think now from here, from here, it should be straightforward, because this is like a typical equation we've been doing since day one. Okay, so you're going to now multiply out, okay, simplify, get your equation into standard form. Okay, so this and that get multiplied, you do the FOIL. All right, 2x times x, 2x squared, 2x times minus 4x. Just remember, when you're multiplying these things, 2x times minus 4. I always tell my learners that when you multiply, you must remember this. Okay, if you are watching movies right now, or at least like if it's you've been watching movies, I hope you always avoid these kinds of movies, the ones that have S, N, and L. They don't really go down well, you know. Like I've never seen them going down so well, so it's always a good thing to avoid them. But what the S and L means is that when you are multiplying out in maths, you must always consider multiplying out the sign first. So the S stands for sign, guys. If you were thinking that it stands for something else, I was saying avoid the movies, but through the S and L, we can understand that when we multiply out, we must multiply the sign, meaning we must think of the signs when we multiply. Then we must multiply the number in that order. And then L, we must multiply the letters. Make sure that the letters are multiplied out, the variables. We apply the appropriate law when multiplying the variables. That's the letters of the alphabet we're talking about. So for instance, when I multiply 2x and x, in my head, I'm like, a positive times a positive, because that's the sign, is a positive. Then I follow it with the number. 2 times, I recognize that there's a 1 here that I cannot see. 2 times 1 is what? 2. Then x times x. You see the letter now. X times x, I keep the base, I add the exponents. There's an unseen 1 at the top here and an unseen 1 there. So 1 plus 1 in the exponent gives me 2. That's what I mean by recognition of multiplication of sign, multiplication of number, multiplication of letter. Always be mindful of that when you are foiling. So as I finish off, what's 2x times minus 4? Positive times a negative, that's a negative. Okay, then 2 times 4, that gives me 8. Then the letter x next door. 5 times x. 5 is positive, the x is positive. What's positive times a positive? That is positive. Then what's 5 times 1? That is 5. Then x next door. Then lastly, 5 times negative 4. Positive times a negative, that's negative. 5 times 4, that is 20. Okay. All right. So I hope you guys are feeling me about this sign, number, letter mambo jimbo. Okay. Star Christie, the live started at just after 10:30. So the 10:30 for, yeah, we've just sort of like gotten into a habit of doing because we build. This is all a build up for the grade 12s that are writing their trial exam. So I'm just trying to get some paper 1 content in. People need to start familiarizing themselves with that. Okay, and it's every day, Star Christie, every day. So we'll see how far we'll go today. I do realize that some people need to wake up tomorrow morning, but nonetheless, we'll see how far we can push today. 1 times x, 1 times 3. Let's transpose the 7 so that we have equal to 0. Okay, equals to 0. Livia is asking why you always focus on paper 1, sir. Like I said, I realize that some people that are in this live haven't been doing, it's been a long time since they've done maths. Okay, I have people that are writing in November and towards the end of this year, so the maths might not be as sweet and cool as it used to be, especially for those who are doing rewrites for end of year November. So the reason why I'm actually doing this is so that they can actually follow along. All right, so I'm going to gradually move away from obviously the topics that I'm doing question 1 and move on to other questions and other topics. Okay, and at some point I'll get to paper 2. Yes, Sinclair, it will be on YouTube. I'll post it when that time comes. Okay, so yeah, but please don't let me hold you back. If at least you've kind of gotten catalyzed by being in the live, don't hold yourself back. Go ahead and go and practice on the side and go and do the questions that are crying for your attention. Negative 8x plus 5x, okay, plus x. What's negative 8x plus 5x? It's negative 3x plus x. That gives us negative 2x. Okay. And then last but not least, negative 20 minus 7, that's negative 27. Negative 27 plus 3, that gives us negative. Okay. Yeah, Blue Car Clark is like saying algebra question 1.3 is my enemy. Yeah, well, algebra question 1.3 is people's enemy because they obviously throw a spanner in the works there. But if you have a good, sound, basic mathematical knowledge and understanding, question 1.3 doesn't matter how it comes. You should be able to actually get out of the woods with those kinds of questions. Doesn't matter how they come. It depends on the person. So 2x squared minus 2x minus 24 is equal to 0. Obviously, we can see that there is a highest common factor. So we divide by that highest common factor. We get x squared minus x minus 12. Okay. You see? So we divide by that 2, definitely. Then of course we factorize. Factors, negative sign means different signs, but the highest factor is going to have a negative sign, so it's negative positive. Factors of 12, yes, Tabo, we have 4 and 3. Negative 4 and 3 is equal to 0. Then last but not least, we solve for x there. Okay guys, zero factor law. Factors, if factors are equated to 0, we can independently write them equated to 0, and then we can solve the linear equations. So we get x is equal to 4, x is equal to negative 3. Okay, my mistake there. X plus 3 is equal to x equal to negative 3. When we are here, we go and we check our answer against the restriction. Go and do what? Check what? Your answer against what? The restriction. Why? Because that's how things are done with these kinds of questions. Okay, that's how things are done with these kinds of questions. Okay, just want to check back and see if all of my mathematics was done correctly before I conclude. All right, because you know what, I am prone to mistakes myself. I'm not perfect. I don't claim perfection, so it's always nice for me to go back and check if my maths was done correctly. Okay, and if you pay very close attention, you'll realize that there's an error that I made. Okay, pay very close attention. Do you see 2x minus 5? 2x minus 5. Do you see what happened here? Have you guys ever done this yourselves? You are writing the paper, man, the maths is flowing very nicely, and for some reason or another, you just happen to change something in the question. Do you see what happened there, guys? No one in this live actually said, sir, no, you did not just change the signs to something that is not there. No one picked it up. Look at you. Blue Clock is saying I did that in trig identities. I know you didn't see, because you know when they, what is it? It's like I've cast a spell on people, and people are just sort of like saying, no, we can rely on this guy. Okay, so please do make it a point that whenever you are seeing me do stuff, just check that I am not altering things, you know, because look, this here is dangerous. This is something that I think, you know, as I mark learners, even myself, I slip. This is a typical slip, you know. This is a typical slip where the sign just changed for some reason. Okay, so I'm happy that I made that error, not because making an error is good, but because learning curve. Okay, no, teachers are not always right, please. Okay, teachers are as human as can be, so if you can make an error, teachers can make an error. There's no such thing. We are not infallible, unfortunately. Okay, no, we are not going to restart. The only thing that needs to happen here is we need to actually change that sign there. But you know that if you had done this, you would have to actually obviously cancel all of this out, because all of this is irrelevant. Okay, you'd have to cancel it out. You know, cancel it out nicely, very nicely and neatly, and then you rewrite. So what I'm going to do, I'm going to just pick it up from where the error was made. Okay, so just be with me here. That 2x minus 5. So I know if it was 2x minus 5, what I would have done, it would have been 2x minus 5 into x minus 4 plus 1 into x plus 3, which is equal to 7. So I'm just going to pick it up from there, guys. Okay, but you know that in a typical test, you'd have to cancel that out up until where you made the error, and then make sure that you do that out. You do that very neatly, okay, and write cancelled, and then you can actually rewrite things from a particular step, or you just make sure that you do what needs to be done. Okay, so if we pick it up from here, guys, because this is where I made the error, this becomes, if I multiply out, 2x squared 2x squared, comment section is cracking me up. 2x squared, 2x squared minus 8x minus 5x plus 20 plus x plus 3 is equal to 7. 2x squared minus 13x plus x, that gives you minus 12x. Then we say plus 20, we transpose the minus 7. Then we basically get 2x squared minus 12x plus 16, which is equal to 0. Then that gives us the opportunity to divide by 2, which gives us x squared minus 6x plus 8. Okay. Then rightfully so, when we factorize, we get x and x. This means that our signs in the bracket will be both the same. Okay. And then the same signs will basically both be negative. Then we have 4 and 2. So then our final answer after applying the zero factor law is x is equal to 4 or x is equal to 2. Okay. Okay, so that makes a bit more sense, from what we did initially. And then what we do from here, we go and check against the restriction which answer is valid and which one isn't. Guys, in our answer we have x is equal to 4 in there, but the restriction says x cannot be 4. So what does that mean? It means we say x cannot be 4 as well, because we are told the restriction says so. Now you see, guys, why it is important to write the restriction. Okay, so that we can make this one invalid. You are invalid, Wena. We don't want you. You are naughty, you. But Wena, we love you. We embrace you. You are the one. Okay, and that's how it is even in life. We invalidate some, we embrace others. All right. So yes. I hope we're good there. All right. So that is just one question that basically we can get, and it's a very common one, guys. Very, very common one that you can get solving for x where it is specifically evident that it's a fraction. And of course, if it is a fraction, then of course you have to apply these procedures so that you can actually make it work. All right, guys, it's okay. Hey, I think all of us, we need to develop a sense of what you might call, they call it emotional intelligence when it comes to people that come into the life. I think naturally, if someone is coming into the life, let's just think about it logically. If someone comes into the life and they see maths is happening, I think it would be natural for them to be like, oh, what are these guys doing, man? It's holidays. I think that's normal. So let's give the people that come in here and they throw their comments a bit of mercy. It's okay. Let's be merciful towards them. It's not too shabby at all. Hopefully they get the picture, and they can just also do the things. I want to do 2 more examples that are not the same as the previous 2 that I've done. Just another one. X squared minus 2x minus 8 over x squared minus 2x is equal to 7. Blue clock, you're asking are prelims easy? Well, if term 2 was not child's play, Blue, then I must say to you that you're just going to have to make sure that you are doing what needs to be done right now. Okay, you are going to have to make sure that you are doing what needs to be done right now. So that's why I'm doing what I'm doing. Hopefully we can be sensitized to realizing that The work that needs to be put in, let it be put in before, there's too much pressure in term 3. There's a lot of work that is being done. So whilst at least we still have a week before schools reopen, let's do something that is memorable, that we'll never forget, that will lay a solid foundation for ourselves. Okay. Yeah. I love what Tabo is saying there. Yes, please, practice. Yeah. 100 days. I was saying to my learners in the province that I'm in that they only have like 55 days. It's literally today 55 days till they write their maths paper 1, according to the timetable that they have, 55 days. And then a little bit more after that, you'll be writing your final. So we need to do some work, that's for sure. Okay guys, look at this example. All right, x squared minus 2x minus 8 over x squared minus 2x is equal to 7. Okay, this type of question, okay, if we were to say, all right, this is a fraction equation again, all right, then what we do is, if we would actually go ahead and apply this method, we factorize the denominator, find the LCD, write down the restriction, multiply each term. There is a problem that we are going to run into. Okay, there is a huge problem we are going to run into, and that is when we multiply the LCD, there is going to be a problem because we are going to be led to an equation that will have as its highest exponent x to the power 4, and that is a problem. It's a serious problem. All right, it is a serious problem. So not all questions that have fractions actually will flow out well if we factorize the denominator, write down the LCD, write down the restriction, then multiply each term by the LCD. This particular situation won't follow down well where that is concerned, because it will lead us to an equation where we have x to the power 4. And I am definitely sure that with the grade 8s, 9, 10s, 11s, 12s that are potentially in this live, we know that when an equation has x to the power 4, we ourselves are kind of not well versed in solving equations of the 4th degree. So then there's something else we need to recognize from the question, and I want you guys to pay attention what that is. So these questions, we call them K-method questions as well. K-method. There's a method that we can apply called the K-method. All right. Now, how do you spot? Hey, what's happening now here? What's happening now here? All right. Now, how do you spot? Hey, what's happening now here? What's happening now here? Okay, I'm sorry about that, guys. Okay, I'm sorry about that. Had a bit of a live intermission there. Okay, can I just ask if my network is also doing funny things? Is my network okay, guys? Can you hear me? Am I audible? Am I glitching? Are we okay? Okay, it's fine now. All right. So K method. How do we glitching, eh? I'm sorry, guys. I really I don't know. 2x minus 8 over x squared minus x is equal to 7. Guys, here is the clue. Do you see this? Do you see that? Repetition of an expression. Repetition. X squared minus 2x in the numerator for a separate term, x squared minus 2x in the denominator for another term. Different, no, same expressions. X squared minus 2x, x squared minus 2x. So that implies that whenever we have a repetition of an expression in our equation, and we can also clearly see that if we were to multiply that LCD, it will lead to an x to the power 4 equation. We immediately turn our attention to the K method. So what do we do here? We simply look at this equation, we take the repetition of the expression, we let K be equal to x squared minus 2x. Aye, that's it. All right. So yesterday we did some exponential equation questions, and there were those quadratic trinomial type questions that needed us to use the K method. I hope you still remember those in your minds, and they are still there. So even with these types of questions here, they are fraction equations, but we cannot unfortunately apply the method that we applied here. We have to use the K method. Why? Because there is a repetition of the expression for two terms where the one expression is in the numerator and the repeated expression is in the denominator of the other term. Okay, so we let K be the repeated expression, and then we go ahead. In the place of x squared minus 2, I'm going to substitute K. K minus 8 over K is equal to 7. Surely this looks a bit more user-friendly, if you want to put it that way. All right. Now we have a LCD, but that LCD is K, makes life very easy. K cannot be 0 as per the restriction. Then all we do now is we want to get rid, it's pretty, Livia. Now we get rid of the K in the denominator by doing what? By multiplying each term by the LCD, which is K. So let's go ahead and do that. We multiply this by K times K minus 8 times K over K is equal to 7K. Imagine if you had that amount of money to actually use for the last few weeks on a holiday. That would be nice, wouldn't it? 7K in the bag. All right. Okay, what's K times K? That gives us K squared. This K and this K, they cancel out. That leaves us with minus 8. Okay, and then lastly there, equal to 7K. Okay. All right, all songs, remember, whether you make it multiply or dot doesn't really matter. Okay, all songs, remember multiplication, there's 3 ways of representing multiplication. You could, I mean, even if I put a bracket, you can either say K times K, that's fine, brackets mean multiply. You could say K, dots mean multiply, or you could say K times K. Multiply also means multiply. So these are 3 different ways of saying the same thing, and all are acceptable. So all songs, it's fine. Okay, if you want to put a dot, please dot away. If you want to put a bracket away. If you, like me, want to put a multiplication sign that it's evident, please, by all means, no penalization will happen because of that. Okay, because all 3 are 100% correct. Take the 7K, transpose it, negative 7k minus 8, which is equal to what? To 0. Okay, then now what can we do? Factorize. So let's open two brackets. We say kk, of course, because k times k will give us k squared. The negative sign means different signs inside the bracket, but the highest factor is going to have a negative sign. Which factors would be appropriate? 8 and 1? 4 and 2? Which one? 8 and 1 or 4 and 2? Okay, all songs are saying 1 and negative 8. Does the grand jury agree? All right, people agree. So 8, which is negative, and 1, who is positive. Then our k values, k is equal to 8 or k is equal to negative 1. Of course, this is coming from the zero factor law. So now that we have our k values, are we done? No. K is the way to x. K is the way to x. This is very important. The k way. K is the way to x. So oftentimes people feel like when they get k, it's like they are done. No, guys. We are not solving for k here. We are solving for x. So k is the way to x. So we come back here to where we let k be equal to x squared minus 2x. And in the place of k, we substitute the k values that we got. Okay, so let's go. X squared minus 2x equal to 8. Or x squared minus 2x is equal to negative 1. Tabo, thank you so much for sharing that. Okay, I think as a former matriculant, I love the fact that you've said in the comment section you used to make that mistake a lot. Tabo, I mark students all the time and they make that mistake a lot of times. They get to K and they're like, yes, yes, yes. And I'm sure like I can see them like celebrating, like 10,000 people watching, you know? Yeah, so it's funny, like all the time. Definitely blue, that is true. So now we can then, after equating x squared minus 2x to the respective k values, okay, we can now solve the respective equations. Get them both into standard form and then solve both of them. Okay, x minus means different signs, okay, and of course the highest factor is going to have a negative sign for the factors of 8. So what are our numbers there? We know different signs, minus and plus. Factors, guys, which ones? Who is factoring? Who is the one that's going to be blue is like saying this part of algebra is nice. Now it definitely is 4 and 2. Okay, and then if you apply the zero factor law, I'm just gonna go straight to the roots. X is equal to 4 or x is equal to negative 2. Okay, does that make sense, guys? So yes, negative 4 and plus 2 are my factors. All right, and then my final roots for this equation is x is equal to 4 or x is equal to negative 2. So I'm done with solving this equation. Let's go to the other one. X squared minus 2x plus 1. So I'm going to open two brackets as well this side. Positive means what? I have same signs inside the bracket. According to which sign? They both are going to be negative. So let's do that. Minus 1. Okay, let me give you a chance to screenshot the previous one. Dgento. I'm sorry for, I think there's someone who said that the network, Spinara is saying this network is not giving. Spinara, I'm going to post these videos onto my YouTube channel. It's just that I don't want to re-explain it's going to make the video too long. So you're just going to have to go to the channel after I'm done, and you can rewatch it at your own time. It's just that time is of the essence right now. I can't really be spending too much time on this. I'm sorry that your network is not treating you well today. Very, very sorry. I hope you screenshotted. The person wanted to screenshot. Final answer here. Okay. You can see it's x is equal to 1. Okay, and I mean, this is the same answer. X is equal to 1 here. We get x is equal to 1 from this bracket. We get x is equal to 1 from this bracket. So we can just write x is equal to 1. That's it. Done, dusted. Okay. All right. So there is that problem. Okay. Okay. Yeah. Tabolebuso, it is when the signs are different. I mean, when the sign of the constant term is negative, the implication is that if the sign for the constant term is negative, that means different signs in the bracket. Then this sign here will tell us what sign the highest factor will have. This sign will tell us which sign will the highest factor receive. So since it is negative, that's why the highest factor is receiving the negative sign. But if this sign was positive, whilst the constant term is negative, then the highest factor would have received the positive sign. Okay, so that is the rule that applies for when we have a negative constant term, because a negative constant term always implies we have different signs, and then this sign will say to us the highest factor gets the sign. On the other hand, when we have positives always says we have the same signs inside the bracket. That's what positive constant term says. We have the same signs inside the bracket, and it will be the same according to this. Okay. So yeah, to my grade 11s, of course, we are wanting to make sure that factorization is something we can do, right? So that's why we make sure that we do it. But as for my grade, the grade 12s, yeah, you guys have the liberty of actually doing quadratic formula factorization, but grade 11s need to get into the swing of things of factorizing. All right, and I mean, factorizing is a skill you need to have, because there's certain instances where you cannot avoid it, But I know some people, obviously, like Livia yesterday showed us, and I think others showed us that they are well able to use the quadratic formula in the calculator, get the roots, and then sort of like rewrite them back so that they get the factors, and then write the roots, after having written down the factors, working back. Okay, so that was one question that has to do with K. I want to show you another one that basically also involves Mr. K. Mr. K is a very I'm sure you guys will immediately, when you see the question, see, oh, okay, this one is also always easily. Okay, can you see, guys, once again, remember the concept I said, the repetition of a particular expression. Yes, this is a third expression, which means this is a third equation, but square root of x minus 1, square root of x minus 1 for different terms is repeated one instant in the denominator, the other instant term as a numerator. So what can we then apply here to solve for the equation? We can also apply what here, guys? Do you see what I'm saying here about Mr. Method K? Mr. Method K is here to save us whenever there's a repetition in the expression for different terms, and we can clearly see that repetition. So K method is there for you. All right. Why don't I allow you guys to do this one? and then someone can guest request, or you can guest request now. You can lead me, and you can do it. I think that would be nice. I'm kind of tired of hearing my voice. I don't know. I know sometimes when people hear someone's voices for too long, yeah. Okay, too sweet. The problem. Okay, so what do we do here? We let k be equal to the square root of x minus 1. That's step number 1. I'm sure, because we can see the repetition, you could probably do this question by, finding the LCD, multiplying out, because what's nice about it is that it won't lead us to an equation where we have x to the power 4. So, I mean, you could utilize that method, okay? Find the LCD, multiply by the LCD, all 3 terms, eliminate the denominator. You could do this question in that method, but K method really just makes life so easy, especially when you can see, oh, there's a repetition. K method is the way, guys. K method just makes life so easy. Okay, simplified, beautiful, nice. Okay, so hopefully you guys are ahead of me. Okay, I hope you are ahead of me. You want to do both the other method and this one? Okay, I'll do it. I'll do the other method too. So k plus 24 over k is equal to 10. Okay, then of course the LCD we can see is what? It's k. So that means we multiply each term by k. When we do that, multiply each term by k. Okay, let me just employ my friend's dot, so just to show you all songs that whether it's writing a dot or a bracket or whatever, it's still fine. There's your dot. Okay, I'm just writing it in pencil there. Not that you should do the same. I'm just doing that because I want you to see that I multiplied. I tend to not show these k multiplying. I just do it like in my head, these things. It looks handsome like this. That's fine. This k and this k, we divide them. That gives us 24. On the other side, you get 10k. Okay, then we transpose. So that's k squared minus 10k plus 24. Man, like I don't know why I'm thinking about money every single time I say k. It's like, it's giving money. We factorize. Factors of 24. Okay, remember the plus sign, that means same signs according to who? According to this sign. So that means in both brackets we are going to have what? We are going to have negative signs. Okay, Olivia has already gotten the final answers there. You can see that in the comment section. Just had my comment restriction. It's filtering out your comment. Okay, there it is. See? Okay, then here we get what? Key 4 and key 10. Okay, so many factors of 24. We've got 8 and 3, that doesn't work. We've got 6 and 4, that works. 12 and 2, that doesn't work. 24 and 1, that doesn't work. So it's always nice when we know our factors very well. Then we know that k is equal to 4 and k is equal to 10. Thank you so much for that. All right, I love the fact that now people are starting to be super vigilant. I say vigilant. Did you hear that? Did you hear that, guys? Vigilant. I said vigilant. Vigilant. People are being super vigilant, and they are calling me out on my mistakes. I wrote 10 here, guys. You see, it goes back to this thing. That's my head. So yeah, 6. All right, so 6 times 4. So obviously that will also be what? 6. Okay, so my mistake, please forgive me for that. And then k means now we can substitute back where k is these values. So we're going to say the square root of x minus 1 is equal to 4, or the square root of x minus 1 is equal to 6, and then we can solve these nicely. Okay, so we know most when we solve this third equation, we square both sides. Thank you, Spelele. Spelele is on the money there. We have x minus 1 is equal to 16, and then that gives us x is equal to, we transpose the minus 1, it's 16 plus 1, which is 17. So Olivia's answer 100% correct there. Okay, we are going to have to check these after we are done, because these after all are called what? Surd equations. We need to check if the answers actually work, both of them. So we do the same thing here, this side, we square both sides. We get x minus 1, we get x is equal to 36 plus 1, we get x is equal to 37. 37. Then we do ourselves a favor. Since this was a third equation type of question, we need to go and check these two answers back at the original equation and see if they actually both work. If they both work, then we allow them to stay. But if they don't, we say goodbye to the one that doesn't work. Or maybe they both work and we don't have to say goodbye to anyone. Or it could be they both don't work. Then we say goodbye to both of them. All right? So let's check 17 and 37 in the original. It seems like from what I'm seeing in the comment section, Livia is saying they both work. Okay, they both work. So let's take 17 there at the top. What's 17 minus 1? That gives us 16. What is the square root of 16? We get 4. Come here. 17 minus 1, we get 16. What's the square root of 16? That's 4. What's 24 divided by 4? We get a positive 6. What's 4 plus 6? It gives us 10. Okay. Yeah. So that's fine. That works. 17 is a correct answer. Let's check 37. What's 37 minus 1? It's 36. What's the square root of 36? It is 6. Okay. So we have 6. Then we come here. What's 37 minus 1? It is 36. What's the square root of 36? It is 6. What is 24 divided by 6? We get 4. What's 6 plus 4? That gives us 10. So it seems like, as Livia said, we are livid and we believe that the answers are both correct. Okay, they are both correct. So the K method, guys, is really like, if there's a repetition of an expression, it's really a user-friendly method. Okay, now I want to explore then the other method, because I think Tabo was like, can you do both? Yeah, so as to give people the liberty of the option. Okay, so Gege, you good? Because I remembered that you wanted me to actually recap since you just joined in. So the square root of x minus 1 plus 24 over square root of x minus 1 is equal to 10. These are equations where we can see there's a repetition of a particular expression. And because there's a repetition, we use what we call the K method to basically take care of the repetition. By substituting K where the repetition is, it leads us to solving 4K, all right? And then ultimately, we use that K value to then substitute back into that let equation that we had, solve for X, because K is the way to X, right? All right, so I'm just gonna do the same question just to kind of show you that this one we could, if we wanted to, solve for X without using the K method. And that is what is the LCD here? Obviously, you can't factorize this, but the LCD would be the square root of x minus 1. So what we do is we write down the LCD as the square root of x minus 1. And then, of course, we would also say that the restriction here is that x cannot be 1, of course. Yes, Letabo. That is exactly what I mean. The K method is helpful in fraction equation situations where there's a repetition of the expression. Okay, we had another situation earlier on, Letabo, where here x squared minus 2x minus 8 over x squared minus 2x, once again for two different terms in the numerator and the denominator, there's a repetition of the expression. So what we ended up doing is we used the K method to solve this equation, because we could clearly see if we didn't and we multiplied by the LCD for all terms, we would get an equation that has x to the power 4, and we do not have the sufficient skills at the present moment within the high school context to solve for x when the equation is x to the power 4 and there's a potential constant term in the equation. All right, so that's why we revert or we use the K method. Okay, the K method, it is the method that will assist us whenever we have a repetition of an expression in an equation, and we can clearly see that that repetition could lead us to some danger like this, or we simply just want to be able to solve that equation quickly and efficiently. All right, so we're looking at the same question, and I'm saying that, well, yes, we could, especially for this one, use the LCD approach, multiply each term by the LCD. All right, so obviously if you are going to multiply, okay, this okay, I'm sure you can see. Then here, I'm sure you can see that if you are multiplying this with that, okay, what do we know we ought to do here? Of course, here this means that we're going to have x minus 1 into x minus 1 underneath the same root. And this will be plus, that to cancel, 24. And then here we have 10 into root x minus 1. Okay. See, so this here is definitely going to be keeping us, like working for quite a bit. All right, and honestly speaking, I personally would not approach this question using this particular method, but maybe for some people they feel comfortable and they feel confident that they can. But I honestly would definitely, whenever I see that there's a repetition, go ahead and use the K method, because it makes life simple, guys. It really just assists so that we have simplicity, you see. You can continue, or someone can continue with this question from this point onwards. I just wanted to show you that, yes, you can move with this question using an alternative method, but I would never, even for my students, I would never recommend that they move using this direction. Never ever. I would rather have them use the K method, because this just complicates life and it makes the problem long and drawn out. Remember, guys, in question 1, that is the question where one is supposed to be collecting marks and should be spending less time in answering the question in and of itself, because you want to move from question 1 and go to other questions and be able to spend more time with questions that need your time. So if you are going to actually draw out the situation, and use a method that will complicate your life, you are the one that's going to be stuck having to solve things. Okay, so I'm going to recommend and suggest K method. That's why I'm basically exposing you guys to the K method, so that you do know, right, that such a method does exist and you can use it when the need requires. Just want to do one last K method question so that you guys can kind of see that, yeah, there are situations that can also be like the following. I'm just going to show you here. Look at this. Look at this question, guys. Look at this one. X squared minus 4x, the whole thing squared, plus brackets 4x minus x squared minus 20. Okay, now I hope you guys are paying very close attention. How many terms in the equation? So this is your first term, all of it, plus this is your second term, all of it, minus 20 is equal to 0. Okay, right? And you can see Thabo Lebuso in the comment section is like, swap the second term, swap the second term, right? And I'm sure you guys can see, okay, why Thabo is saying swap the second term. And then All Songs follows it up by saying the plus sign will change to negative. Okay, I'm glad that we are seeing these things. So if you look at the first term, this is x squared minus 4x. The order of the terms, very important. The variable with the highest degree followed by the variable with the least degree of the exponent. But look at this one, 4x minus x squared. The order here is a bit messed up, all right? It would be nice if the x squared would start and then the 4x would follow, because then we'd have a repetition of the expression. But this repetition of the expression is needed. Why? Because if I don't do that, let's say I open two brackets of x squared minus 4x. Hey, let me just show you this. Let's say, because I know some people, they want to be Superman or the Powerpuff Girls, and they want to save the day, you know. So x squared minus 4x into x squared minus 4x, or maybe they want to be this guy. They want to be this guy. Who knows, eh? Maybe they want to be this guy. All right, x squared minus 4x into x squared minus 4x. Guys, this here, you see, if you multiply this with that, what will happen? You are going to get an equation where you have x to the power 4. All right, and rest assured, you are going to have a constant term at the end. X squared to the power 4. Can you solve for x where there's x to the power 4? So this is another situation where you can see the equation will lead you to x to the power 4. We don't want that. It's going to complicate our lives, very much so. All right. So I'm going to take a step back. I'm not going to go that route. It's a problem. Okay. Yeah, because I have wisdom. It's informed by the things that I know. So let's go back. This x squared minus 4x is fine. It is squared. And as was suggested in the comment section by Thabo, all right, this is what Thabo Lebuso said to me. Swap the second term. So x squared minus 4x. Let us apply the procedure of SCR. Then after that, All Songs said the following. Plus sign, meaning this sign, will change to minus. But I need you to understand why that is going to be the case. Remember that whenever we swap around and there's a negative term that is second and we swap around, we take out a what? A negative sign. Very, very important. We take out a negative sign. So I want you to understand that, so that when my sign changes all of a sudden, okay, because remember, if I take out that negative sign, it is now in competition, or it is now being multiplied with a negative sign. This positive and this negative sign are now being multiplied. So I need to resolve those two signs. So when I continue, I have x squared minus 4x, the whole thing squared. What's a positive times a negative? That gives me a negative. And then I have x squared minus 4x minus 20 is equal to 0. Now please check again. Do you see my equation? Do you see this bracket? Do you see this bracket? Are these brackets the same? That's my question to do. Are these two different terms? Are these brackets the same? Are these two separate terms? Yes. Are they the same, the brackets? Yes. So what method can I then use? Because there is what? An expression of x squared minus 4x is being what? Repeated. A repetition of a expression. Okay. Does that make sense, guys? All right. So Tabalubuso said transpose the negative 20. But no, we don't. Okay. We use the K method. Okay. We use the K method. So we are going to, at this stage, let K be equal to x squared minus 4x. We could see that if we opened this bracket and we applied the squared, we are going to run into a problem of an equation with x to the power 4. We don't want an equation of x to the power 4 because we don't know how to solve an equation with x to the power 4. So we use rather the K method because there's a repetition of an expression in our equation of x squared minus 4x. All right, so we let K, hey guys, K method. I hope you guys are seeing this thing, all right, this K method usage. Okay, yeah, and once you see it in the place of K, in the place of x squared minus 4x, I'm writing K. That's followed by what? By squared. Minus. Okay, K. That's K minus what? 20 is equal to what? 0. Okay, but Boddington, that's true. Okay, we definitely need to make sure that that does happen, what you've said in the comment section, because we've been saying that K is the way to X. We've been saying this all the time, right? That K is the way to X. So when we get the values of K, we know we are not done. We know very well we are not done because K is the way. You know, K is the way to X. So different signs, remember, because our constant is negative, but then our highest factor will have a what? A negative sign. So the factors of 20, seems like in the comment section you guys have already given me a helping hand. -5 and 4, 100% correct. All right. Then from there, guys, it's a matter of writing down our values of K. Does that make sense? So K minus 5 obviously is equal to 0, or K plus 4 is equal to 0. Maybe some of you may have noticed that sometimes I do write the steps, sometimes I don't. Sometimes I go directly and I write my K values. Okay. And honestly, if you move from the factors to the K values, that's 100% correct. If you omit to write this step and you simply move from here to there, that's 100% correct, okay? I just am making sure that I write this step for teaching purposes so that you guys know what I did, okay? Not missing out a step simply because I need to always emphasize to the people that are seeing me do the maths that yes, there's a critical essential step which has been done, which has led me to writing down the K values as such. Now, are we done? No. As our beloved friend Boddington, I don't know how you guys come up with these names. K method is good, just make sure you sub back to the original before solving. That's what Boddington said. And we did say initially that K is the way to X. So there, our equation. I'm waiting for who? I'm waiting for who? For K. All right, so x squared minus 4x, here you go, get your first value of K. x squared minus 4x. Here you go, get your second value of k, which is negative 4. Then we solve these independently. Standard form. They are both now ready to be factorized. The first one, different signs, but the highest factor is going to be negative. So this is 5 and 1. And then of course, x is equal to 5 or x is equal to negative 1. Okay, just be careful. Okay, and then lastly, this one, same signs according to who? This one. So both signs are negative. Then it's 2 and 2 equal to what? 0. Final answer, x is equal to 2. All right, remember that this is one answer at the end of the day. Okay, all right. Tabolibus is like saying I use a different method, is not used to the K method. No, I hear you. Okay, some people are able to see that this is quadratic in nature, you know, just from there, and so they are able to utilize quadratic solving, you know, whilst they retain the x squared minus 4x, and then ultimately they are able to get the answers as well. So that's fine. Okay, just like I said, guys, K method is just a simplistic way. It's just we need to make sure that we never forget repetition of an expression. This is saying K method. Okay, so I want to just summarize for you that, you know, in your question 1 type questions, there are basically 3 questions that warrant us using K method. The first one is when we have an exponential equation, okay, and this is just made up, so that does not mean that if you solve this you are basically going to get a situation where you'll get your solution. I've just made this up. Okay, this here is a typical K method needed equation, because it's an exponential equation. When you have 2 terms in your 3 terms of the exponential equation, the exponent for the base that is the same, one coefficient is 2 times the other. We did this yesterday, guys. 1 is 2 times the other. K method is used. You remember, we let k be equal to 3 to the power x. Guys, I'm not going to solve this. I just want to make the point. Okay. Then your second question, where K method tends to be required, is a situation where you have 3 to the power, let's say x, and then there's a 5 times 3 to the power negative x, and maybe there's a plus 7 equal to 0. Goes down there, you have the 7 there, and of course, because you have this as 3 to the power x, you multiply each term by it, it leads you back to a situation like this where k needs to be utilized. You let k again, and then you solve for k first, and then later on for what? For x. Okay, I'm just exposing you to the scenarios that warrant k. Now we've just looked at repetition of expression in an equation, and you've just seen, guys, this scenario warrants K method, because the minute if we multiply, we are going to be led to x to the power 4. It means we cannot solve the equation with x to the power 4. So we need to look for the repetition of the expression and then use the K method. So I'm saying the repetition of the expression type questions require us to use K method. These are the evident 3 scenarios from question 1 that need K method usage. Okay, so I just wanted to summarize that for us so that we know and can note when K method needs to be utilized by you and I. Okay, I don't know if there's any pressing comments, questions, concerns, queries, la-la-las, and more la-la-las. Are we fighting the enemy, guys? Is the enemy getting like thrashed by us? Like ba ba ba, the maths ba 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 ba. Goodbye. Adios, muchachos. And so Akimudisa is saying, can I please do question 2 example? Can I please? You want to do it? Okay. Yeah, you can definitely do it. It's like if you want to do it. So yesterday, and I just want to kind of go to a similar question, okay, because this would be a question that is like that. Okay, yeah, yesterday there was a question like this: 5 to the power x. Okay, so immediately you look at this question, you're like, GK method, ngwanesu, GK method. All right, but it needs a bit of work first. All right, and I mean yesterday, I think people were able to do it. You see, someone yesterday did it. I wasn't the one doing this. Me, I was just asking people. Someone did this question. Mara GK method. Yo, GK. Question 2 type. You see, base. How many terms? 1, 2. There's the third term. This is an exponent. 5 to the power x. The base is 5. The base is also 5. This x is a positive exponent. This x is just negative, different from this one. So K method is going to be utilized. We know at some point K method is going to come. You see, look at this one. 3 to the power 2x minus 4 times 3 to the power x plus 3. This here is 3 to the power 2x. This here is 3 to the power x. This 3 and this 3, different terms, the bases are the same, but look at the coefficient of x. This one is 2. This one is 1. So the one is 2 times the other. Hey, baba. Hey, wena. Entate. Hey, look at this. 3 to the power 4x. 5 to the minus, let's say it was saying minus 5 to the power 5 times 3 to the power 2x. Guys, I want you to see this as well. This is 3 to the power 4x. The base is 3. This is a separate term, this one. This is 3 times 2 to the power x. Let's say minus 8. Guys, this is made up, right? So if you're going to solve this, you're going to run into problems. I'm just trying to emphasize the point of K method. Once again, the bases are the same for different terms, right? This coefficient of x is 4. This coefficient of x is 2. So obviously, when we let k, we are going to let k be the base that has the lowest exponent. But what do you notice about the coefficient? One is 2 times the other. And that relationship of one being 2 times the other, baba, GK. But it's just that in this instance, my letting k will be k is equal to 3 to the power 2x. So as long as the coefficient relationship for my x variable exponent is 1 is 2 times the other, GK. Okay, GKK kamuvango. All right. It's KK, guys. KK is like making his way into maths. Like I don't know if you guys KK is making his way in maths. So that's why I'm saying KK. Yabo. K. It's okay. It's K, it's okay. It's okay. Yabo. Maths is okay. K. Now we've just been exposed to what? To repetition of expression. Yabo. This repetition of expression for different terms, numerator, denominator, K. You see, we let K be the repetition, and then it makes life so easy. And we remember also that never do we ever, not ever, ever, okay? Never do we ever, not ever. We don't ever. When we use the K method, end with K, because K is the way to X. Okay? K is the way to X. So I hope you guys have seen what you need to see, right? And I want to maybe say that if we can see that, then it's fine. There was someone who said in the comment section, can you please do inequalities? The funny thing is, the person who's asked me that question, inequalities, we were chowing inequalities the past few days, right? Tina, inequalities, they are not, our inequalities are just things that, yeah. What's happening? Can I enjoy it? What do you want to enjoy, Jody? We only have a week, Jody. Really, we still have a week. Oh, Jody Shem. Jody, get with the program, good sir. We need you, Jody, to come on board, you know. Yeah, guys, the next term is very short. Before you know it, the term is going to be over, and then final exams will be upon you. Okay, so please make it a point that oh, Jody does maths lit. Oh, okay, well, Jody, then that's fun, buddy. Well, you good then. You fun, buddy. You fine. Thank you so much, Jetro. Thank you for the roses, man. The gift section has been very quiet. It's funny because I kind of miss him. Mrs. Him is not here today, it seems. No, that's fine, Jody. That's fine, Jody. Jody guy. All right. Okay. Do you guys want to? Do you want me to give you some problemos to do? All right. Let's see. This is Western Cape, guys. Western Cape. Look at this question. Look at it. 1.1.4. Can you guys do that for me? 1.1.4. Trial exam, Western Cape 2024. Look at that. And then you say, well, this guy, we want problem always. I like that. I actually always love when that thing comes on. So, okay. So let's give you guys a chance to do number 1.1.4 for me. Let's see if you guys have gotten the concept. If you guys want to have a field day maybe with everything, maybe should I give you guys a chance to just maybe now it's my time to just keep quiet and allow you guys to flow. Let's see. We've been doing all these problems, so 1.1 up until 1.3. Okay, this is a simplified question and it's exponents. Let's just see. You guys can, let's do this. Let's start there at the top. I'll give you time. How much time? 2, 3, 5, 5 plus 4, 9, 9 plus 5, 14, plus 6, 20, 23. All right. Yeah, let's do all of this. 29. So it's good. 30 minutes. That should take us up to, let's see, 30 minutes. Yeah. All right. Let's do everything that's here. Okay, I love the integration. All songs, we hear you there. Okay, So are we good, guys? Can we be on point now and do this? Up until 1.2, is that what you're saying, Olivia? Up until 1.3. Okay, so let's do it up until 1.3. Okay, let's start from 1.1.1. So I'm just gonna zoom in a little bit so that you guys can see the questions a bit clearly. So let's start 1.1.1 and we can take it up until 1.3. Okay. Yeah, so I will tell you now how much time I'll give you since up until 1.3. 5 plus 4, 9, 9 plus 5, 14, 6, 20, 23. You have 23 minutes. So at exactly 6 minutes past 1, 3 minutes past 1. Yeah, so exactly 3 minutes past 1, you should be done. Actually 6 minutes past 1 to be exact. So 6 minutes past 1, you should be done, everyone. So have a crack at it. I'm gonna remove the comment section if you don't mind. And I guess we don't have to, yeah, that's the mark allocation so that you guys can see the mark allocation. Yeah, there we have it. So 1.1.1 is x minus 1 into 2x minus 6. That's 1.1.1 is equal to 0. The second one is x squared minus 7x minus 7 is equal to 0. Answer correct to 2 decimal places. 1.1.3 says 6x squared plus 7x greater than 5. 1.1.4 says 1 is equal to negative 6 over the square root of x plus 2 plus the square root of x plus 2. Then 1.2 is a simultaneous equation. We have 6y plus 2x is equal to 4 and x squared plus xy is equal to 4. And then 1.3 says simplify without the use of a calculator. The square root of 3 times the square root of 48 minus 4 to the power x plus 1 over 2 to the power 2x. So that is the entire thing. And I will be so I've taken off the comments in the comment section on purpose so that people can do the problems without referring to anything and seeing each other, seeing each other's comments. Okay, we should be done, right? I think that was sufficient time. Now imagine being writing that trial exam paper and it's up. You should be able to say time is up indeed. And you are also done, you are finished. So hopefully we are done. We are done. Okay. I need someone. Okay. So let's come on, okay guys, and let's do the things that need to be done. Those that have been here in the live, especially those that haven't had the chance to actually lead us through, I'd love to have people come on and join and just request. You can request, please, so that we can do these together. I'd love some people who haven't actually come on as guests yet. I'm hoping your environment will allow you to come on and actually lead us through. That would be much appreciated. Okay, or it could just be the regular people then. I mean, all you want to do is just get the corrections done for all of these problems, and then yeah, we can call that a day, its night, and all of its things. One by one is more good. One by one. So in no particular order, guys, anyone can come through, it's fine. I think that this thing of limiting is some people may feel like, I was here yesterday. I wanted to give other people a chance that maybe have not requested and come on and led us. So come on, guys, please. I don't want to do them myself. I want someone to lead me in doing them. It's better that way. Then at least I can also get a sense that, okay, people are gaining something, you know. That's what I want ultimately. And remember, guys, me actually saying time is done, remember that at some point when you're writing that paper, time is going to be done whether you like it or not. So unfortunately, I can't keep those questions on the live for too long. All songs, you're back.
Yes, sir.
Back in the future. So, brother, let's go. 2x minus 1 to 2x minus 6 is equal to 0. 2 and done. Let's do this one, and then I'll give you 1 point as well. This is yours.
1.1.1 is mine.
Yeah, and 1.2 as well.
Oh, 1.1.1. So that equation is already factorized. So we just get straight to the point and write the answers. So since it's 2 marks, Vel.
What are the answers?
X equals to 1.
X to 1.
Or 2x minus 6 equals to 0.
Okay, 2x minus
or you can say
6 equals 0.
Then 2x equals to 6. You transpose the 6 to the other side. You divide both sides by 2. And then x equals to 3.
All right. That was so smooth, eh? From the man himself. Second question, x squared minus 7x minus 7 is equal to 0, and there's a answers correct to 2 decimal places.
And then when it says correct to 2 decimal places, you already know that you must use a quadratic formula. So, just that I didn't finish it, so I don't have a calculator on me. I just inserted the numbers where they should be, and then I just left it like that. Minus b plus.
Okay, that's the beautiful quadratic formula as you had indicated.
So our a is 1, and then our b is minus 7, and then our c is negative 7.
Okay, definitely, thank you.
Yes, so you say minus, and then you open a bracket, and then you put minus 7.
Yeah.
Plus minus. And then you square root, square root. And then on the b you put a bracket, since it's negative value. You put a bracket, and then you say minus 7 squared. And then you subtract 4, and then you open a bracket, and it's 1, yeah, out of 2. Our a is 1, and then you say 2, you open the bracket, 1, you close. I finished there, since I don't have a calculator.
All right. So there, that's comment section. So it's 49 plus 28. 49 plus 28, 49 plus a nice 28 will give us a beautiful 77 over 2. Then we use our calculator to get the answers respectively. In the comment section, what did you guys get for your 2 answers rounded off to 2 decimal places? Let's see if the amazing, beautiful people that were doing the problem have common answers. X is equal to come on, wherever you are. Okay, Olivia is saying 7,89 and negative 0,89. Negative 0,89 and 7,89. Okay, Saint FX also agrees. All right, so I will take you at your word, believing that it is well. All right, epic. Mr. All Songs, it seems like the lyrics have been well set. The song is being sung very well. And it's a new song, Baba. It's a new song. Okay.
Yes.
Thank you so much for that one. I believe the next one is 6x squared plus 7x greater than 5. Livia said wants to take that one. So is that fine? We can allow to live on the live. Okay, let me just request. It's more cautious says that's two. Okay, it's fine.
Okay, I think it's okay. Ngoku. Ndiyavakala? Hello?
Yeah, very well.
Sir,
Hello.
uyandiva?
Yes.
Okay.
Yeah.
Question 1.1.3. So can you please just write out the question first, like the problem?
Yeah. So 6x squared plus x is greater than 5.
Okay, so I'm having a network
In
issue
there,
here.
yeah. It seems like I'm also
Okay,
having a joint issue there.
and then I just want to get it to standard form, right? So it'll be 6x squared plus 7x minus 5 is greater than 0. Okay, perfect. And then now we have to factorize, right? So it'll be open parentheses 2x minus 1 close parentheses, and then open parentheses 3x plus 5 close parentheses is greater than 0.
All right.
And then we write down our critical values. So 2x will be equal to 1, and then x is equal to 1 over 2.
2x is equal to 1 and x is equal to 1 over 2.
And then you say and 3x is equal to negative 5. And then x is equal to negative 5 over 3. And then say, can you please draw a number line and then indicate negative 5 over 3 as the first term, and then the next term will be 1 over 2.
Okay. Negative 5 over 3 with 1 over 2.
Okay, and then yeah, that's perfect. So due to the fact that our coefficient of x squared is positive, we now know that our graph is a happy graph. It's smiling. It's a happy parabola. So we'll draw an upturned parabola. And then because we know that our problem told us to find the values of x for which the function will be greater than 0, can you please just indicate the part where the graph is over the horizontal asymptote?
So that's this region above the x-axis.
Yeah, x-axis. Okay, and then I like to use the interval notation. So I'm gonna say x is an element from negative infinity to negative 5 over 3, and then union 1 over 2 to positive infinity. And that is the end of our problem.
Okay, so with this interval notation that you have there, is there anything like, is there any brackets?
Yeah, there are brackets. You should have written a bracket before the negative infinity, and then after the negative 5 over 3, and then before the 1 over 2, and after the positive infinity.
Okay.
And they are round brackets and not square because the function it's just greater than 0, not greater or equal to 0. So that is why the brackets are round instead of square.
Okay, thank you so much. Wow. All right, then just back here, if we relook at what you did, okay, so you first made the inequality, you wrote it in standard form, you then factored, okay, and when you factored, you then went ahead and you wrote 2x is equal to 1 and x is equal to half. Is there anything here that should be included?
The critical values, should you write like CV?
Yeah, definitely. No doubt. Okay. So please, guys, yeah, the thing is, if there's no CV here, then we write CV there with an indication that we acknowledge these as critical values. So please make sure that that is the case. Otherwise, that was my only this part was my only cry here. Yeah.
Okay,
so let's make sure
noted.
noted indeed. And then also, I love the fact that you use interval notation, and I love how you explain that the reason why you use round brackets is because the greater than sign there means obviously for the function, the answers lie above the x-axis, because this means above the x-axis. So we don't include the critical values, rather we exclude them. So this is how you would write your answer in interval notation, but also you would be 100% correct if you said x is less than -5/3 or x is greater than half. If you wrote the answer this way, this would also be 100% correct as opposed to writing it this way. Otherwise, I have no contention at all where that is concerned. Are you happy to lead us with the next one as well?
Yes, I am, sir.
Yeah, okay. Kill too bad. All right.
So the next one is question 1.1.4, which states that 1 is equal to -6 over square root x plus 2 plus square root x plus 2. And then immediately we should be able to see that there is a repetitive pattern going on with the square root of x plus 2. So we should let k equal to the square root of x plus 2.
Amen. Hallelujah.
And then 1 is equal to -6 over k plus k. And then to get rid of the denominator, I have to multiply all the terms in the problem by k. So the next step will be k is equal to -6 plus k squared. And then k squared minus k minus 6 is equal to 0. That might be confusing for some people because I just moved the terms to the other side instead of this side, but then it just disturbs me when the 0 is on the left side, so I just choose to write it like that. But it's not a problem if the 0 is in the left side instead of the right side. I hope that's clear. And then we should factorize on the next step. So open parentheses, k plus 2, close parentheses, open parentheses, k minus 3, close parentheses, equal to 0. And then k is equal to -2 or k is equal to 3. And then that is not the end of the problem solving, because we were not solving for k, but we were solving for x. So instead of k now, we replace that with the square root of x plus 2, because initially we said we should let k equal to the square root of x plus 2. So we're changing that now, like we're replacing the square root of x plus 2. So square root of x plus 2 is equal to -2. And then we should, and the square root of x plus 2 is equal to 3, or.
Yeah.
And then we should raise all the terms to 2. So
Okay. All the terms, I tell you.
all the terms. And then x plus 2 is equal to 4. And then on the other side, x plus 2 is equal to 9. And then on the left side, x is equal to 2. On the right hand side, x is equal to 7. And then because we're dealing with surds, we should check if our answers are correct. So we should substitute 2 and 7 in the place of x from the initial problem to check if it equates to 1 or not. So I did that, and x does not equal to 2, but x does equal to 7. So we're invalidating 2 and validating 7.
So both of them don't make it.
No, x is not equal to 2, but x
Oh, okay.
is equal to 7. So we're invalidating
Oh,
2, but validating 7.
okay.
So that is the end of the problem.
Neat. Okay. And can we all in the comment section confirm that this is actually like legit the end? That 2 does not make it. Like, unfortunately, we have to say goodbye, dearly beloved, to 2, but we embrace 7 because 7 is legit. So Minentle says yes, definitely, agree. Got a sharp sign there in the comment section.
Yeah. I'm glad it's correct because I was kind of panicking for a moment there.
You were kind of panicking. Yeah, no, I think that was actually very nicely done, very smooth. I think I'm gonna ask this question again. Are you sure you're not a teacher?
I'm not, sir. I'm not a teacher. I'm in grade 11 and I
You're in
have
grade
never
11.
taught anyone in my life.
Oh, okay. Yeah. I think it must be that for the first time when someone is explaining and they are using brackets, they actually utilize the word parenthesis. Then you know for sure that I it's next level. It's next level.
Yeah, I learned that from a movie I once watched. It was a Spanish movie, so like it was kind of cool. It was about a school. I'm not sure of the name. It was called Diaries on Netflix, and then I learned the name and I was like, oh, that's a cool name. I should use that next time I'm in class just
I
to
see.
impress my classmates. And then I got used to it, and now I use it on every single equation that has brackets in it.
Yeah, you just use parentheses. No, it's actually quite cool. Also, I think I saw someone say in the comment section, the accent, guys. It's super. I think Tabole Bus was saying the accent is just a killer.
Funny thing about the accent. So I grew up in the Eastern Cape, specifically studying in a rural area, like in a public school in a rural area.
You
And
kid.
I was fluent in English from grade 3, and that is not because of the school. It is because I watched a lot of English cartoons. Like I've never watched what are those cartoons that played on SABC 1? Never have I ever watched them. Like I used to watch Disney Junior, Sophia the First, and that is how I actually learned English. And then when I
Oh
came
wow.
here to Cape Town, my classmates were so shocked. They were like, "Are you sure you're coming from a rural area?" And I was like, "Guys, I've been studying in the rural area all of my life."
Oh wow.
What? That's so unexpected, but yeah.
That's amazing. That's amazing. You must keep that up then. And yeah, that's quite an interesting turn of events. The fact that I think a lot of people they naturally would have the assumption that if someone is speaking like that, Model C school for sure, that one, it's like she drank tea with the queen, that type of thing. But yeah, so that's epic. That's epic. Thank you so much for walking us through that problem, step by
Yeah.
step. And yeah, you can see most even in the comment section. People are quite impressed. So thank you so much, Livia. It's always good to have you in the live. And yeah, let's see who we can get next for the next and the next problem. Thanks a
Yes,
ton.
sir. Thank you.
Cheers. All right. Bye. Who will be our next victim? All songs were saying that I taught plenty. Livia was one of the learners I taught in 2022. Really? Is that legit? Oh my goodness. So it was just like a sir and teacher sir and student moment. No. I think it's because all songs is getting all these compliments in my comment section that the way he seems to be able to pick up on things. I think Samantha was quite impressed with how he seems to catch on to comments in the comment section, and he's quick to correct certain things that seem to be off, off the mark. So I mean that's quite impressive, no doubt. We let's give Smongotlo. Smongotlo was like Smongosi was like he wants to do the last two. So let's give the man a chance.
Hello.
Hey Baba, you good?
Yeah, I am good. Hey, you got me up these days. Hey.
I got you up these days. No. Me, I don't get people up. People get themselves up. If you're up, you must know it's your choice.
Yeah, hey. You gotta do what you gotta do. Hey.
I'm telling you. We out here fighting, eh? We out here fighting.
Hey, it's crazy. Oh, I don't know how
Yeah.
crazy it is.
There's no other way.
Okay, let's get down to business.
Sure, Baba, let's get it. 6y plus 2x is equal to 4, and x squared plus xy is equal to 4. Now this problem is nice.
Can you just give them names? The first one, can it be the first equation, and then the other one the second equation?
Neat. Oh man, why do I have a sense of deja vu? It's almost as if I've heard you say this before.
Wow. I always do that just for. Okay, now we're gonna make the first equation at that equation. So can you please write the first equation for me? Then we'll simplify it.
Sure. 6y plus 2x is equal to 4.
Okay, so can you please just take a common factor of 2 and just divide the whole thing by 2?
Okay. That's giving me 3y plus x is equal to 2.
Okay, so can I please disappoint you here? Firstly, I tried doing it with an x, but then I noticed something was off with my equation because I was trying to write fast because I arrived after time. You see, because you said at what. Okay, so please transpose the x to the other side, and you'd be left with 3y is equals to and 2 over x. 2 minus x. Sorry.
Okay, 2 minus x.
Then you divide by 3 on both sides.
Okay, divide by 3 both sides. That will leave me with 2 minus x over 3.
Which is the third equation. Can you name that?
Equation 3.
So you substitute that equation into the second equation.
All right. So that will be x squared plus x into 2 minus x over 3 is equal to 4.
Okay, so now we will have x squared plus 2x minus x squared over 3. 2x minus x squared over 3 equals to 4. Then you just multiply the whole equation by 3 just to get rid of that 3. Then you have 3x squared plus 2x minus x squared is equals to 4.
Is equal to
12, man. Why?
Hey, epic. No problem. I'm glad you caught yourself on that one.
Yeah. So now I have 2x squared plus 2x minus 12 because you'll be transposing the 12 to the other side, which is equals to 0, and you divide everything by 2, you're left with x squared plus x minus 6.
Okay.
Equals to 0. Then you have open 2 factors, open brackets, x, there's 3 and 2. Yeah. Or you can do it as all songs did it yesterday. You just take out the whole factors 6, 1, 3, and 2. Then you choose which ones will give you 1, but then you'll have an x and an x there, then you have a 3 and a 2, then you'll have a 3 positive and a 2 negative.
Okay, nice.
Then you have an x equals to negative 3 and an x which is equals to 2. Then you take those answers, you have to substitute them to the first equation to get the y values.
All right, so our equation,
y is equals to
y is equal to
2 minus
2 minus
it was negative
negative 3.
Oh yeah, it was negative 3, yeah, because I just left my book there. Okay, then you'll have an answer which is 5/3.
Definitely. So that will give us 5/3.
That's the first answer. Then you have another y minus
Y is equal to 2 minus 2 over 3,
which is just 0.
Yeah, so that's 0/3, which is actually equal to 0.
Yeah, that's yeah.
Okay, that was not too shabby. Okay,
the way that made me do this, because when I did it with x, I think maybe someone also did it with x and then they got only one answer for x and one answer for y. So that's why I did it with y, because you have the full answers when you do it with y. Because when you do it with x, I think the 4's cancel out and then you don't have a y there. You just have a y which is equals to 0 and it will give you one answer. So
yeah, I think you should still be able to get the values if you when you made x the subject, you should still be able to get the two answers. The answers will still come out.
Yeah, that's why I think I'm saying I think I'm the one who made the mistakes. Because
you made a mistake. Oh, okay. So that's why you.
Yeah, I just did it with the y because I thought maybe I did something wrong and I wanted to keep up with the time.
Okay. No, I get you.
Yeah,
I get you.
Yeah. Let's do the other one then.
Samantha, just hold on a sec. I see Samantha saying 11/9. Okay, and I think that might be that there's some sort of error that Samantha made. Samantha, were you able to get so you didn't get the same answer, Samantha? Sorry, man. I just want to make sure that everybody who's actually in the live, because you're supposed to get x is equal to -3, x is equal to 2, and the other should be y is equal to 5/3, and y is equal to 0. Okay, so yeah, if you make x the subject, still so I think Samantha, there's just something that you may have done incorrect. All right, and maybe it would be nice if definitely, Samantha, if you can request, please come on through and then we can actually chat about your response and what happened. Okay, so let's go and do the next one.
Can you please write it there? Yeah. Okay, I think it's okay.
√3 times √48 minus 4 to the power x plus 1 over 2 to the power 2x. And all this is saying is simplify without using a calculator. Simplify without using a calculator.
Use of the calculator.
Yeah. There we have
okay. So the first thing we need to do, we need to we have a √3 first, a √3, then I think I have to split the 48. So what I usually do, I usually think of when I see some things like that, I just try to simplify the 48 to the smallest numbers that I have. What do they call the numbers that are divisible by 1 and the number itself? They call it
prime number.
Yeah, they call them. So I try to always simplify the number to the prime numbers. So when I divided the number 48 by 2, I saw Uguti there's 24, and in 24 when you divide 24 you have you have 4. Okay, you have 4 and then you have 8. Okay, so when you have now I see I have 4, I have 8, I have 3. So I saw there's something that's there. Should see leo is 2 raised to 4. Then when you reverse it, 2 raised to 4 it becomes 4 raised to 2. So I just said, okay, because this answer is like this, I'm just going to take it as it is then. Total 3, because the 3 is on par with the other root 3. So I just said a root of 3 times 4 squared.
Okay. Okay, which is perfect.
Which is still the 48 now. Yeah. Then minus, then you continue with the sum. I'm coming back to that thing.
That's fine.
Minus 2 raised to 2 into x plus 1 for no, yeah, okay, yeah, divided by 2 raised to 2x. Okay, then I come back here. Now I have a root 3. Now I have a root 3 times a root 3 times root 4 squared. Minus is my network not okay? Yeah, minus 2 raised to 2x plus 2. Okay, divided by 2 raised to 2x. Okay, so now root 3 times root 3 will give me 3. Then times
root 3 times root 3 is 3.
Okay, so a root 4, then the root and the square, they cancel out times 4. What's happening to my connection? Okay, then you minus 2 raised to 2x plus 2 minus 2x. Is my connection not okay, or is it yours?
Yeah, your connection keeps on. It's your bars. I can see.
Yeah. I don't know what's happening because I'm in my room. Okay, so now the answer is 12 minus the 2x and the negative 2x. Hello? Yeah, it's 12. Then there I have 2, right? Negative 2, not 2x. They will cancel out. So 2 squared. I have 2 squared. So yeah. Then the answer is 12 minus 4, which is 8.
Okay.
Yeah.
Well done. That was so smooth. That was so smooth. So nicely done. All right, good job, buddy. Joe, good job. All right, so I like how you used the 48, you broke it down into 3 times 4 squared, which was amazing. Okay. Yeah. And then you were able to actually break it down again with its respective square roots. And then you were able to see that root 3 times root 3 gives you 3. The square root of 4 squared, obviously the square and the square root, they cancel. So you can say 3 times 4, which is 12. And then here, this side. Yeah, man, like exponential laws here were used completely. From changing the composite base. We call this a composite number. So it's a composite base because it's a base that has more than 2 factors. Changing that to a prime base, okay, 2 squared, and then ultimately being able to distribute the exponent, which was amazing, and then being able to apply law number 2 of exponents. When you have the same bases, you keep the base and you subtract the exponents. So 2x plus 2 minus 2x, getting 2 to the power 2, which is 4. And then obviously 12 minus 4 is 8. I think
Yeah.
it was, who's this? Someone said they don't understand. Saint FX, you lost me at root 3 times 4 squared. Right, so what we try and do, okay, sure. What do you want to say?
Oh, like the upon this thing of the sets, and I think that you can get it with more practice, because people don't think the same way, because someone would have thought it at it on another way, but then arrive at the same answer. You know what I saw would see when I because I have that root 3, so I have to do something and have a 3 in that 48. That's what I tried to do, and magnificently, then I got another 4 squared, which just like takes out the root. And you know the law of roots is also applied when you're multiplying two variables in the same root. You can separate the root. You see, so you just need to get some practice. But what I did is just 3 times the whatever, then just get it. Yeah.
Very true. Thank you so much for that. So, guys, here we use something that we refer to this as writing this number as a product, meaning a multiplication of a prime number and a perfect square. Because 4 squared here is what we refer to as a perfect square. It's a perfect square number. So obviously, when we apply a square root to a perfect square number, what happens is that we are able to get a natural number, which is 4. On the other hand, 48 here, now if we multiply the 16 with the 3, we then do get what? We then do get that 48 back. All right. Now, remember here, this did say simplify without using the calculator. So what that simply means, it doesn't necessarily mean that, for instance, if you want to basically break up 48, you wouldn't, for instance, I know some people would probably come here and say 48 is equal to, and then they'll say shift, and then they'll press fact. And I'm sure when you do that, what do you see? You get 2 to the power 4 times 3. Do you see that? Yeah. So what we could have done is utilize the calculator. Utilizing the calculator doesn't mean that if you can't go to your calculator and actually write down the breakdown of 48 using your calculator. You could have well written 2 to the power 4 times 3. That's okay. What they are saying by when they say don't use the calculator, they are saying they don't want you just punching this in root 3 times root 48 and just writing 12. Because if you do that, then there's no steps of simplification that I can see that led you to the answer. So when you say square root of 48, and by the number inside the square root, you begin to actually break it down using your prime factors or your prime factorization by saying 48 is equal to, and then saying shift, then pressing fact, and then getting that, that's fine. That's perfectly fine. All right. And that's one way. Okay. That's why I think Swangusha was saying that, depending on who you are, and the amount of practice that you may have gotten simplifying surds, simplifying exponents. Someone else could have written their breakdown using 3 times 4 to the power 2. Someone else could have said 2 to the power 4 times 3. Someone else could have said 16 times 3 and put that in the square root.
Yeah.
And then split the 2. Square root of 16 times the square root of 3. Square root of 16 is 4, whereas the square root of 3 is retained. So it just depends who's doing the problem. But what's fundamental here is that, remember, when they say without using the calculator, it doesn't necessarily mean that a calculator per se cannot be utilized if it so be that you don't know how to break down 48. What they don't want is you actually just punching into the calculator this here and then writing 12. I get there, it's like, it's a no-go zone. Okay. So I hope that makes sense. So once again, if we can go over what Mongusha said, square root of 3, he broke down 48 into a prime number and a perfect square. And that's perfectly fine. The square root of 3 And obviously here you can then split the square root of the product, as I indicated yesterday. So we can write this as the square root of 3 times the square root of 4 squared. So since you have the square root of 3 and the square root of 3 there, it means the square root of 3 times the square root of 3. Remember that the square root of 3 times the square root of 3 is the same thing as the square root of 3 times 3. All right, which is basically 9. We know that the square root of 9 is what? It's 3. Or you can say the square root of 3 times the square root of 3 is 3. I hope that makes sense. And then 4 squared, the square root of 4 squared, that gives you 4. What's 3 times 4? It's 12. Then you can simplify that. All right, so hopefully the third, the square root, the root, okay, makes a bit more sense. And yeah, guys, practice. I cannot overstate utilize the resources you have at your disposal and make sure that these basic laws, the basics to surds and exponents, are sorted out. Okay. Yeah, sibonga okuhle baba.
I'm still here. I'm still around. I'm just listening. I'm looking at the comments and many things. Yeah, but I'd like to emphasize like the thing of surds, like because I've seen a lot of people like being frustrated by surds. Surds are very important. They're very easy because they go hand in hand with laws of exponents. But when they want to make a high order question, they just use these simple laws, and people don't want to study these laws. They are very important. Yeah,
that's very true. Very true. Thank you so much, Sibonguhle. We thank the goodness. Eh?
My pleasure.
Sure. Samantha, I'm looking for you because I'm sad that you feel the way that you do. Is it possible for Samantha to request, or is Samantha unable to request given home setup? If not, I guess then not. But like I just wanted to say, like, I mean, sometimes when as you do problems, there are times when you make errors, and you know those errors are supposed to be opportunities to learn. I think you need to take those very positively and see them as opportunities to learn, because that's important. So that's why I wanted Samantha to actually, if possible, if she is able to, let me see if I can't extend the invite to her and she can accept my request. Okay, so that we can just rehash and go over the problem, solve for x simultaneous equation, having made x the subject instead of the other, you know, making x the subject. 6y plus 2x is equal to 4, and the x squared plus xy is equal to 4. Right. Sam to the nth.
Hello.
Hello, how are you?
I'm good, thanks. And are you?
I am doing very well, thank you. I'm doing very well. Thanks for accepting my request, and I'm sorry if it is that it's kind of a bit of an inconvenience. I wanted to look at this problem, the one that you will be crying in the comment section.
Yes.
Yeah.
I'm okay. Mina, I used x as my subject of the formula.
Which is fine. Which is fine.
Yes.
So can you just lead me so that we can see where we went and so forth.
Yeah. Okay. I use the first one, 2x.
So this one.
Yes.
So 2x.
Yes. I said 2x is equals to 6y minus 4.
is equal to 6y minus 4. Okay.
Yeah.
So Samantha, just from the get-go, right? We have 2x, and you can see the 2x on the left-hand side is positive, right?
Yes.
The 6y is also positive on the
Positive.
left-hand side. So if you take the 6y over to the right, what happens to the 6y?
It changes the sign.
Yeah, it becomes
Negative
negative.
6y.
And the 4 is already positive on the right-hand side. So the 4 keeps its sign.
Okay.
Does that
So
make
I
sense?
think, yeah, it makes sense. I think that's why I made a mistake, because I used 6y minus 4.
Okay. Yeah.
Yes.
Yeah. So do you see how in actual fact, like, so that minor error is just it. Otherwise, like, there's and that's important for you to be able to see that, and then actualize that. Okay, so that's what I did wrong, so that the next time and the next time and the next time you do the same problems, you don't
Yes.
find yourself repeating that same error, because you kind of realize the impact it's had on this particular solution, this one that we've just done.
Yeah. Seems
Yeah.
like that problem of the science is following me everywhere. So.
You'd be you're not the only one. The thing is, signs tend to give people a number. They pull a number on a lot of people. So it's just a matter of being very vigilant, especially with equations, that the minute you transpose a number to the other side, you need to be vigilant that, okay, hey, this guy is going over, like, crossing over Jordan. So miracles are happening, Red Sea moments are happening. There's definitely going to be changes happening, major changes. You can never be the same.
Okay, sir. So since I've seen my mistakes, can you please uh invite all songs, or what? I think he said he did
Okay.
it using the X. Maybe I can see.
Okay. All
Yeah.
right. Let me have him up. I know he was like begging me in the comment section to come up, and help you along.
Yes, I'll be. I'll be.
Let's get the songster in here.
Okay.
All songs, you've been summoned.
Yes, sir.
Yeah, you have been summoned. So I think you need to take us through from this point onwards, so that yeah, I think Samantha has immense confidence in you. So please, let's go ahead, and you can
Yeah,
help us.
from there you should make x subject of the formula, so you divide all the terms by 2.
Okay, so we're gonna divide all the terms by 2, so each respective one.
Yes, so you get x equals to
Okay,
or minus 3 plus 2.
minus 3y plus 2.
And then that's your third equation. So that one, your 6 plus 2x equals to 4 is your first, and then the other one is your second. Then that one is the third.
Okay, second, sorry, then that's our third. Thank you. Okay.
Okay, so I can say you put or you substitute 3 into 2.
So we substitute.
3 into 2.
Okay, very true. So we substitute this equation 3, which is this one, into 2, as we have been told. Okay, so that's equation 2. That's equation 3. Yes.
And then you're gonna the second that one Yeah, there, and then you put that x, you open a bracket there.
All right, let's open a bracket.
And then you put that minus 3y plus 2. And then you square.
Amen. Yes.
And then you say plus. And then the x again, you open a bracket. And then you say minus 3y plus 2. And then you close, and then you write that y. It's multiplying y. Yeah, equals to 4.
Okay.
So, yeah, and then on that one, you can maybe, for those who don't understand, you can like break that one off squared. Just, yeah, plus 2. Yes, just like that. And then you say plus y. And then you open the bracket, you say minus 3y plus 2 equals to 4. Samantha, if you don't understand here, tell me, please.
Amen.
And
My,
then,
hey, my leader. When all songs, I think when you're a veteran teacher, I know ways.
I do understand.
okay.
I'm with you every step.
Samantha,
Sir,
tell me, don't you think this guy is a veteran teacher? I'm also starting to have these feelings now.
I said it, sir. He just didn't see my comment.
Hey, this guy, I
Yeah,
call.
it's good. It's good.
Okay, let's go about all songs.
Oh, hey, the guy says, whoa, like he came method, but then I don't want to use that one, and I don't think
Yeah.
maybe Samantha you
Let's
see.
let's not use that one. Let's just continue.
Okay, so from the first one, yeah, you're gonna take that minus 3y and then multiply it with minus 3y plus 2, and also take that 2 and then multiply it by, yeah.
Okay, there we go. The FOIL method.
Yeah, negative 3y times negative 3y is positive 9y squared.
Amen.
Then you're gonna take negative 3y times 2 is negative 6y.
Yes.
And then you go to the 2. And then it's positive 2 times negative 3y is 6y. And then it's 2 times 2, which is 4. And then, yeah, you're gonna say you add. Okay, y times negative 3y, and then y times 2. And then it's negative 3y squared.
Okay.
And then it's positive 2y. And then you can just transpose that 4 and then make it negative 4 there. And then as you see, there is a positive 4 there and a negative 4. So it's 0. That means, yeah, that one you won't do it. So, yeah. And then 9y squared minus 3y squared equals to 6y squared.
Okay. Those are like terms, so we can add and subtract them. 9y squared minus 3y squared. That's 6y squared. Thank you.
And then there is, let me see, 6y minus 6y, and then plus 2y is 10y minus 10y
Amen.
equals to 0.
Equal to 0.
And then from there, you can see where like 2 can get into 10 and 6. So you're gonna take out 2y because that 10y, it has 2y, and yeah, and then you're gonna open a bracket. And then you're gonna say 6 divided by 2y equals to maybe 3y. And then you write 3y. And then there on that one, you say minus 5 because the 2y is already out. And then you close the bracket equals to 0. Yeah, Samantha, you get it? Samantha,
yes.
you
I
understand?
Yes, I understand. You see, on that step of 9y squared minus 6y minus 6y. Uh, the negative sign that I was supposed to use on top, uh, that's the one that made a mistake, because I ended up getting 12y squared minus 14y. You see where you've got 6y squared minus 10y. Yes.
Yeah. Yeah.
Yeah. Yeah. But I'm seeing it.
Yeah.
I'm with you all the step, all the way.
That's
Okay.
good.
Okay, therefore say 2y equals to 0,
Sure. 2y is equal to 0.
or 3y equals to 5. Or you can write it minus 5 for those who don't understand, and then you transpose it to the other side. Minus 5 equals to 0. And then from that side, you divide this side at 2y. You divide
Okay.
all sides, both sides by 2. And then you get y equals to 0.
Epic.
And then you go to, and then 3y, you transpose it to the other side, is 3y equals to 5. And then you divide both sides by 3.
Yeah.
Then y equals to 5 out, 5 divided by 3.
This guy.
And then you go back to that the equation number 3, and then you put the y values there, and then you get x. So x equals to minus 3, and then you put 0 there, and then plus 2. And then any number multiplied by 0 is 0, so it's 0 plus 2, which is equals to 2. Yeah, and then you go to the other side. It says x equals to 2. It's 3 minus 3, and then you open bracket 5 divided by 3, and then plus 2. And then as you see that 3 there, and then that 3, this first one, the first one, that one is the numerator, and then there is divided by 1 there. So it's gonna cancel that other 3 there. So it's gonna be like it's gonna be minus 5 plus 2, which is equals to minus 3. Yeah. We're done.
Yeah, over to you, or songs. You can just check with Samantha and everything, you know.
Yes. Samantha. Sis Samantha.
I say, from now on, I'll be calling you sir.
Amen.
No, I mean you are good.
We're giving it to him as all songs. That's I don't.
Yeah.
I think
From now on.
Yeah, I think I will be here Fridays, mostly Fridays and Saturdays. I will always be here because Monday I'm working until Friday, so I have to sleep early.
Okay. Yeah. Well, we're glad to have you, buddy. That's for sure, no doubt. Because you definitely stealing hearts here. You can see even there in the comment section, and even like with just the explanations. I've been seeing your comments as well. You know, it's like you pick up on things very quickly. That hey, there's that particular thing. You know, that should be done. That there and so forth. So your presence is very much appreciated, sir. So thank you so much for helping out Samantha there and making her feel, you know, seen. I think that's very important, you know. And Samantha, thanks for actually, accepting the request, because I think it was even Tabo earlier on was saying, please, Samantha, request, so that you can sort out this minor maybe glitch or problem that may have resulted in you not getting the answer. So I mean, I even appreciate just the community in the people in shepherding you there. So thank you so much.
Okay, thank you.
Yeah, thank you
Also,
guys.
you are an amazing teacher. Thank you very much. Thanks.
Thanks, Bob.
Sure.
All right. Thanks, guys. Let me discharge. Get you. Thank you so much, guys. Yeah. So I hope that was clear for all of us. And yeah, so I think that's going to be it for today. I'm actually a bit bushed here. Bushy thing. Tabo, you can say that again. Samantha is extremely confident. Let me just see what these, because I just see some spinara. Is it spinara or spinach? What's happening here?
Hello, sir.
Is it spin?
Can you hear me there?
Yeah, no, I'm good. And you?
Yeah, I'm good. Can we go to question? The last question. There's something I can show you an easy way to simplify that one.
This one.
Yeah. So anytime when I deal with this question to simplify, so every time when I simplify this, they say simplify without you use a calculate. So there's an easy way to get an answer before you simplify. So, say, can you take your calculator there? Yeah,
Okay,
please write this equation. Where there's x, please replace 1.
Sorry?
So, please write this equation.
Which
Where
one?
there's
This one?
x, please replace. Yes. Where there's x, please replace 1.
Where there is
Where
x.
there's x, please put 1.
Okay. So you want me to rewrite the whole thing. So root 3 times, is that what you're saying?
Yeah.
Root 48 minus, then we say 4 to the power 1 plus 1. 2 to the power, 2 to the power, what am I doing here? 2 to the power, me is slipping, 2 to the power 2, because that obviously that would be 2 to the power 2 times 1, so that would be 2 to the power 2. Okay, there it is.
Yeah.
So what must I do now?
So press answer there.
I press
Answer.
There's my answer.
Yeah. So that's how I deal with this equation before I simplify with it.
Oh. Okay.
Yeah.
So that you can see what the outcome will be.
Yes.
Okay. And then after that?
Yeah, you're gonna simplify. After when you simplify, you're gonna match the answer. If the answer look the same, which means you are correct then.
I hear you. Oh, so you just simply replace
1
with the same number.
Yeah,
but
always. Yeah, always put 1.
Oh,
Yeah.
wow. So the answer, you begin with the end in mind already.
Yes.
Hey, this guy. Hey. Hey. Hi, people have tricks of the trade. And where did this one come from, Spinner? Yeah, it's like now I'm thinking of that song, Spina Pine Moyene. Like when I hear this name, Spina.
Yeah.
Yeah.
I
So,
do research every question that I get.
yeah, okay.
Yeah, that's all I do.
No, that's epic, man. No, it's something else. It's really something else. No, that's epic. Um, that's epic. All right. No, I see that. Yeah, I think it helps obviously with the finality of the answer as far as this specific simplification question. But yeah, of course, I think what you have also said is that it's important for people to then be able to actually solve it, which is important. Okay, and simplify it. Otherwise, thank you for that, Baba. Yeah, thank you for that.
Okay,
Is
so
there? Yeah, no, you're welcome. Tabule Buso. Seems like people are like they don't want to sleep, eh? They want to do more. Okay, no, that's fine. No, I don't mind, guys. If you want to do more, let's do more. Let's turn the attention to something else. Number patterns. Okay. Let's turn the attention to number patterns. Are you guys ready for number patterns? And I think let's start. I'll start, and probably for just today, can I bring exponential equation before you leave? Okay. No, I'm not leaving, Fede. But if I think you wanted to request, let me give you a chance. You have an exponential equation that you want us to look at. Okay. F-E-D-E-H-E. F-E-D-E-H. You can come on through. Okay. Question 2, guys. All right. What type of sequence is this? And obviously, we're just going to actually give this kind of sequence a chance. And I want to actually maybe, before we get into it and get too deep into it, I want us to get a conceptual understanding of the concept of this sequence. Now, I believe my beloved grade 11s have not as of yet done quadratic sequences, unless, of course, you guys are part of certain programs and you are attending programs for mathematics where those programs are already exposing you to certain concepts already. If they have, then that's great. I'm very happy for you. So is there anyone who else besides Livia that I know who is in grade 11 and has not done number patterns as of yet? And by that, I specifically mean quadratic number patterns. Okay, because I just want to do a quick brief summary before we get into questions relating to quadratic number patterns so that we get everybody on board first and foremost. Quadratic number patterns. Anyone who has not done number patterns, quadratic number patterns yet? Okay, because this is under the topic in grade 12 of sequence and series. Okay, so is like, that's one of the best topics. Okay. So there's no one who's in grade 11 here who's like, no, me, I don't know what you're talking about. All right, so I can just go ahead and press. You want to help with that? Okay, guys, we'll get there. I can see. So people now, are feeling the fire. They want to come out of the crevices. Gamo, my beloved Gamo. So Gamo is like, I haven't done it yet. Is that correct, Gamo? You haven't done quadratic number patterns yet. Okay, so let's look at it then. First and foremost, what is a quadratic sequence? A quadratic sequence or number pattern. A quadratic sequence or number pattern is a sequence whose second difference is constant. I repeat, a quadratic sequence or number pattern is a sequence whose second difference, and this is like the important word, second difference. The second difference is constant, not the first difference, but the second difference is constant. The general term of a quadratic sequence is Tn is equal to an squared plus bn plus c. I repeat, the general term of a quadratic sequence is Tn is equal to an squared plus bn plus c. So, if we think about it generally, let's say we want to find out what term 1. Remember, n in number patterns means position. It refers to the position of the term, this n, okay? Is what we refer to term. Okay. Now let's say I want to find out what term 1 is in terms of a, b, and c. So if I say term 1, what is term 1? Term 1 is equal to, I'm going to substitute in the place of n, 1, a into 1 squared plus b into 1 plus c. What does that give me? It gives me plus c. So term 1 in terms of a, b, and c is a plus b plus c. Let's check what term 2 is. Okay, term 2, that means we go back to the general term of the quadratic sequence and we substitute 2 in the place of n. A into 2 squared plus b into 2 plus c. What does that give us? It gives us 2 squared is 4, so that's 4a. B plus b times 2 is 2b plus c. Whilst we add it, let's find term 3 in terms of a, b, and c and substitute into the general term. So we do the same thing, a into 3, b times 3 plus c. So all I'm doing is I'm finding in terms of a, b, and c term number 3, the third term. So 3 squared is 9, so I have 9a. B times 3 is 3b, and then plus c. And then I'm just going to roll with just one more. Let's say term 4, and let's just check what term 4 is. Term 4 is equal to a into 4 squared plus b times 4 plus c, which is 16a plus 4b plus c. Now, if I look at all of these terms in terms of a, b, and c, if I was to list my terms, this is a plus b plus c, it's term 1. The second term, 4a plus 2b plus c. Third term, it is 9a plus 3b plus c. And then fourth term, it is 16a plus 4b plus c. Please take note, this is my quadratic sequence in terms of a, b, and c. My first term, second term, third term, fourth term, and I mean I could list all my other what? My other terms. Now I want us to check something out here. All right. Are you ready to check out what I'm going to check out with you? I want us to find the first difference. What do I mean by first difference? I want us to find out what term 2. Remember that to find the difference between two terms, you take the later term minus the previous term. Later term minus the previous term. Later term minus the previous term. So what I want to do is I want to subtract T2 and T1. All right. So when I do that, it is simple. I'm going to subtract, and you can see, guys, that for term 1, I have A plus B plus C. For term 2, I have 4A plus 2B plus C. All right. So that means I am going to simply take term 2 and subtract term 1. And when I do that, okay, it's simply this. 4A minus A. What's 4A minus A? 4A minus A, because I'm subtracting the like terms. What's 4A minus A, guys? Okay, all songs, it's 3A. Let's move on to the next term. 2B minus this B. Okay, because remember, I'm checking here T2 minus T1. So therefore, when I'm subtracting the like terms alone. 4A minus 3A, 4A minus A, we got 3A. 2B minus B, I get positive B. Thank you so much, Samantha. Then C minus C gives me what? It gives 0. So that means my C term simply is gone. All right. So let's move on. No need to write the 0. Very true. Let's move on. Let's go to T3 and subtract T2. And let's do the same exercise. That means we are going to subtract like terms. T3 minus T2. 9A minus 4A. What does that give me? 9A minus 4A gives me... I'm going to wait for you guys to let me know in the comment section so that... Thank you, Samantha. Samantha is like off the blocks. Like, Samantha is off the blocks there. It's like we've got our Noah Lyles. Sharika Jackson of Mets Game Athletics. Then 3B minus 2B. What's 3B minus 2B? 3B minus 2B gives me what? Positive B. Very good. Then lastly, C minus C. What does that give me? All right, I'm sure you guys can see that C minus C, it seems like it gives me Mamshengo, 0. Okay, right. Then let's move on to the last two terms that I have in my sequence. 16A, because I'm going to take term 4 minus term 3 now. Okay, so what's 16A minus 9A? 16A minus 9A. Yes, I get 7A. Thank you very much. 4B minus 3B. What does that give me? 4B minus 3B gives me 4B minus 3B. Yes, gives me positive B. And then last but not least, what's C minus C? C minus C. Because remember, we are taking T4 minus T3. So because the subtraction is towards the negative, this side, that's why all of these are referred to as negative. Okay, that gives me 0. Very good. Okay, guys, what I want you to know is that what I've just done is we have just found the values of my first difference row from the quadratic sequence, which was these terms. All right, these are my first difference row terms. Okay, and I'm going to speak and say more about them, but for now, let's hang on there. Let's now go to my second difference. And let us see what is the result of the second difference. If we take now, this is my first term in my first difference row, my second term in the second difference row, and my third term in the first difference row. So what's 5a minus 3a? Okay, everybody's like saying 2a. And then what's b minus b? That's obviously going to give me, b minus b is going to give me 0, right? Thank you so much, also. So that means I only have 2a for the second difference. Let's check what is happening when I take 7a plus b minus 5ab. What's 7a minus 5a? What do I get? 7a minus 5a? That will give me what exactly? Okay, 2a. And what about b minus b? B minus b gives me 0. Thank you so much. Now, listen up. This here is my second difference row. And what do you observe about my second difference row? My first term in the second difference row is 2a. My second term in the second difference row is 2a. So yes, indeed, the expressions are the same. They are constant. They are the same. I love what you guys are saying there in the comment section. Which is why if we go back now to the definition of what a quadratic number pattern, I need you guys to understand the concept. A quadratic sequence or number pattern is a sequence whose second difference is constant. What does the word constant mean? It means the second difference is the same. And we have just used the general term of the quadratic number pattern, substituted positions to get terms in terms of A, B, and C, and now we have been able to conclude that indeed the second difference of the quadratic sequence, generally speaking, is indeed constant. Okay. Now I also want to indicate the following, that the first difference row is a linear or arithmetic sequence. The first difference row is a linear or arithmetic sequence. Now, the word linear should be a familiar term to many of you, given that in grade 9, in actual fact, in grade 8 and in grade 9, you were taught linear number patterns or linear sequences. Grade 8, 9, 10, all right? And then in 11, it was revised, or it's supposed to be revised in grade 11, as you make your way then to doing what? Quadratic number patterns in grade 11. It's only in grade 12 that you guys are also taught that a linear pattern is also referred to as a arithmetic sequence. These are terms that are synonymous. In other words, they mean the same thing. A linear pattern is the same thing as an arithmetic sequence, just as much as an arithmetic sequence is the same thing as a linear sequence. So only the original sequence forms a quadratic sequence. The first difference actually forms a linear pattern. The second difference is constant, all right? And it makes sense because if you know what a linear pattern is, you will know that a linear pattern is a pattern whose first difference is constant, all right? Yeah, but a quadratic does not have a first difference that's constant. It has a second difference that is constant. And that is very key. The following expressions are also of great importance. The ones that I am doing what? That I am putting a square around, or a rectangle if you want. A rectangle actually. A plus B plus C is the first term of the original sequence. 3a plus b, generally speaking, is the first term of the first difference. 2a is the constant same second difference for my second difference. And these expressions are very useful when we have to calculate the value of A, B, and C for a given pattern where we want its general term or equation. I repeat, these expressions, A plus B plus C, 3a plus b, and 2a, are valuable expressions that we use to calculate the value of a, the coefficient of n squared, b, the coefficient of n, and c, the constant term, whenever we need to find the general term of a quadratic sequence. I hope you guys are actually with me with what I've just done right now. If you have a question, I would invite you to post it in the comment section if there's anything that is really unclear for you. I'm now going to do an example where I show you how to find the nth term of a general quadratic number pattern, how to find a term if you are given the general pattern or equation, and then lastly, how to find the position or the value of a particular term in a given sequence if that position of that term is of a higher position, all right? Or vice versa, how to find the position if I'm given a specific term in the sequence. Okay, let's look at a few questions maybe that could be guiding questions towards that end, and then let's see. Okay, so that is just a nice intro summary if you want into quadratic patterns. You know, I'm looking at these past papers and it seems very clear that, you know, look at the Eastern Cape question 2 paper that was written for the trial exam. Given the quadratic number pattern, there it is, -5, -4, -1, and 4. This question is saying determine the nth term of the quadratic pattern in the form Tn is equal to an squared plus bn plus c. How many marks? 4 marks. Let me show you then how we proceed. So I'm going to first write the pattern. Okay. And the clue is that we are told from the statement that given the quadratic number pattern, so we are told this is a quadratic number pattern. Okay, right? So let's write it down, the original pattern. Then it becomes your duty that after you write it down, you have to then set up as finding the first difference row and the second difference row. Now, how do we do that? It's very simple. This is -5, this is -4. When we want to find the first difference, we say term 2 minus term 1. So in other words, -4, remember T2 minus T1, that means -4 minus -5. Very important, guys. -4. The formula of T2 minus T1 already has a negative sign. So what I need to do is when I say -4, I need to say minus because the formula has a minus sign. But then this term is negative as well. So therefore it means I say -5, which simply is -4. A negative times a negative gives me a positive. So my answer here is -4 plus 5, which is 1. So that means 1 belongs here in this position. All right, maybe you guys can tell me the rest. What is -1 minus -4? What is supposed to be here? I'm going to listen from you and then you can tell me in the comment section. All Song says it's 3. Okay, I'm not sure. I will hear from you. Okay, Kamo and everybody else saying 3 as well. Then next one, 4 minus 1. Remember the formula, or it has a negative. 4 minus, this is a minus negative 1. So what's 4 minus 1? Samantha, 5. Thank you so much. Now look at this sequence. Do you remember what I said? The first difference row, what kind of sequence is formed by the first difference row? Livia, definitely it's arithmetic, or in other words, we can use another word instead of arithmetic. We can say this is actually a, if it's not arithmetic, it's linear. Definitely, very good, blue-faced. Okay, guys, arithmetic and linear are synonymous. All right, we can use those interchangeably. Then, if we go and now establish the second difference, what are we going to do? And what is the answer? Is it going to be constant? What is the answer here? Samantha says it's 2. All songs is agreeing. Livia is definitely supporting it. We've got a trio, ladies and gents. It seems like we can confirm that the answers for both are 2. 3 minus 1 is 2. 5 minus 3 is 2. Now you will remember what I said to you earlier on. I said in the positions of 2, 1, -5, there are expressions that help us or aid us in being able to find, because remember, what did they say they wanted? They want the general term of Tn is equal to an squared plus bn plus c, which means we need a, we need b, we need c. Here, if you remember, when I was doing the general term of an squared plus bn plus c and substituted 1, I found my expressions, but specifically I put a rectangle here, there, and there. What expression belongs in the place of 2a? I mean of 2. What expression belongs in the place of 2? All songs says 2a. Do we agree with all songs? Do we think all songs has lost his marbles? All right, it seems like we all agree. So 2a is equal to 2 is what I'm going to equate. I'm going to take the expression 2a and make it equal to the value of 2 that is in my second difference, first term of my second difference row. So 2a is equal to 2. Can you solve for a here? Okay. Then we solve for a, guys. It's as simple as that. Then we solve for what? For a. Let's solve for a. 2a is equal to a, 2. What's the value of a here? Livia is livid in the comment section and is saying the answer is 1. Aye, we are flowing, guys. The next thing that we need is b. So what we do is we move one step up. After we find a, it means we are good. We move one step up and we go and check on the next expression in the next row, the first difference row, the first term of the first difference row. The next ring, what expression belongs in the place of 1? What expression belongs in the place of 1? Did you write it down? Do you remember the expression that belongs in the place of 1? Did you guys write it down? Do you need me to go back to my diagram and show you what the expression that I had put a rectangle around that belongs in the place of 1? Oh, we didn't take notes. They need me to show them. Oh no. All right, let me go show you, guys. Do you still remember? 2a, you guys were correct. The next ring of my ladder, the first expression that is in the position of that 1 is actually what? 3a plus b. So this expression should be equated with what? This 3a plus b should be equated with who and why? 3a plus b is equal to 1. Are you with me? Which one? This one. Because 3a plus b is in the place of 1. That's why I was saying to you guys, these are important expressions that we need to always remember. Unfortunately, there's no formula sheet that will remind you of these expressions. You need to be accustomed and acquainted to the expressions. That is why I was doing what I was doing earlier. This was not for mere entertainment and fun, guys, in as much as I would like to believe that maths is entertaining, and I am particularly entertaining when it comes to mathematics. You know what I mean? You know what I mean? But I mean, this 3a plus b expression should be equated to who? To that one. It's always equated to whatever number belongs to this place. So this now will assist us to find the next letter. All right. All right. I can definitely see this one that you have typed that's saying, sir, I'm sorry, but my comments are not appearing in your screen. Can you see this one? So I can definitely see that one. So 3a plus b is equal to 1. Now, 3, the a, I already have it. Oh, how important it is that this a is correct. Imagine if this a is incorrect. Imagine if I make a mistake with this a. Then it means that when I come here and I want to substitute the a that I had gotten, right? Guys, this a comes from the a that I got above. I come and I substitute it in the place of a in brackets, plus b is equal to 1. Now I can solve for who? For b. 3a plus b is equal to 1. Sorry, I just had to move out this. Okay, not c. Okay, yes, that's why I'm, Okay, so there we have it. Okay, 3 times 1? 3. All right, then what do? I transpose 3 over to the other side. B is equal to 1 minus 3, so B is equal to negative 2. All right, it's coming, guys, it's coming. So we have A, that's 1. We have B, that's negative 2. Who do we need now? We need the value of C. Where are you, C? We need to go to the next ring of my ladder. You see, we were here, Moss. 2a is equal to 2. We solved for a, we got it. We need to move to my next ladder, my next level of the ladder. I took 3a plus b, equated it to 1, and solved for b. Now I need to move to my next ladder, negative 5. Who is negative 5 interfering with? Samantha, you are 100% correct. Negative 5 is interfering with a plus b plus c. Samantha, you couldn't be more amazing right now. So let us go and write a plus b plus c. That expression. We equate that expression with what? We equate that expression with negative 5 equal to negative 5. Do we have a? Oh, a we do. We have a. Come, a, come, a, and take your place. Come, a, and take your place. 1. Do we have b? Come, b, and retake your place. All right. Please, guys, when you're answering these questions, don't draw these arrows. Me, I'm just trying to obviously make the point. Do we have C? No, that's who we're looking for. And obviously, whenever we are solving for something we don't know, it's nice when that variable is the only thing that needs to be still found out. Every other one is taken care of. That's why we needed to find A. There it is. That's why we then moved on to find B. There it is. So that we can use the last ring of the ladder to basically find the value of C. Okay, then we add. Remove the brackets. 1 positive times the negative minus 2 plus c is equal to negative 5. Then we keep Mr. C. We transpose everyone else. Negative 2 has been particularly negative nowadays on the left-hand side. When he goes over, look at him. Look at negative 2. All of a sudden, he's all happy and jolly because he's got a positive attitude. Take 1 over to the other side from the positive left-hand side, positive, it becomes negative. Then C, what's the value of C? You tell me, guys. Let's see if you guys have still got your addition mojo jojo in your heads and everything is still good. Minus 5 plus 2 minus 1, that gives us who? Tell me, what is the answer? I think Mr. It's like the Doug Landoga of Moss. You know this guy. He's the main guy. Minus 5 plus 2 minus 1, that gives us negative 4. So C is equal to negative 4. All right. Now remember, the question had said determine the nth term of the quadratic number pattern in the form. Okay. Its name is Sonic. Tn is equal to an squared plus bn plus c. So what do? We found a, we found b, we found c. So a, we have 1. So that's like 1n squared. B minus 2n. C minus 4. This here is the nth term of the general term of the quadratic sequence. Was that too bad, guys? Was that too bad? Was that bad? Was that okay? Did that sound sweet and good? Like, you think you guys can do this? Like, I mean, nth term, getting the nth term. Okay. So that's why I was saying, you must know him. You must know him. And you must know him. And we always start from the bottom, then we hear. We started from the bottom, now we hear. We started from the bottom, now we hear, We start from the bottom, then we go up there, Requires a lot of work, but easy. No, definitely easy, okay? You might find as well that in this manipulation of algebra, obviously I've done step by step, but I'm sure some of you, for instance, 3 plus b is equal to 1, you'll be able to do it mentally and get the answer. But you can see, guys, sometimes the dragging out is for the purpose of clear explanation, so that no one says, I don't know what he did there in that step. It doesn't make sense, Look, you see, all songs is even like vetting me out. In the comment section there, say you ask a question that needs no and ask another that needs yes, and I answer how. Tell me, this guy, who would be asking those kinds of questions unless you've got skills in being a teacher, and now you are just, you're seeing this guy who's just like butchering it. He's not doing it the way it's supposed to be done, and you're just seeing his weaknesses. This guy, I tell you. Right. 2.1.2, calculate the 5th term of the quadratic number pattern. 5th term. No, the 35th term of the quadratic number pattern. I'm telling you, Olivia, I'm telling you, your guy is just something else. He's a workhorse. Calculate the 35th term of the quadratic number pattern. Now, you've seen questions like this even from linear number patterns. So to calculate the 35th term, guys, what are they saying? They want T35, in other words. That's what they want. That's what they mean by 35th term. Okay, so if they're saying 35th term, they're definitely asking you for T35. In the place of n, you are substituting who? 35, which means in the quadratic number pattern you found, you are substituting who? 35. Thank you. So 35 squared minus 2 times 35 minus 4. Then you grab your calculator for me. You do it for me, please. Grab your calculator for me. Okay, thank you so much, guys. That was well answered. Okay, and then the last term. Last question. Which term in the sequence? Oh, which term in the sequence? Yeah. Yes, I will, Miss Him. I've actually uploaded all the others, but they are still, I've made the videos private. I've not actually made the videos public yet. So I've uploaded all the others as well, but I'll definitely upload this one after I'm done. Okay, which term in the sequence is equal to, and these questions tend to be very important, which term in the sequence is equal to 479. Yeah, I must say, Miss Him, kind of missed you here in the live. Yeah, but I'm glad you're at work. At least productive there. You see, no one has been doing this, guys. Mrs. Him rocks up. Thank you so much, Miss Him. Really appreciate it. I told you last time that me, I'm a guy of what you might call, my love language is gifts. So those are really appreciated. Thank you so much, Mrs. Him. Really appreciate it. I hope you safe there at work. Safety is important. So which term in the sequence is equal to 479? Okay, see this question, which term in the sequence is equal to 479? So this question is different from question number 2. Okay, if they are saying which term, they are asking us for the position. They want us to find out the position of the term in the sequence that is equal to this value. This is the value of the term, and what we want its position. So in order to do that, we say Tn. Yes, we need n, in other words. Very good. Hey, Samantha is on fire. Okay, so Tn is equal to 479. We equate, okay, Tn with 479, and then as the teacher there, our one and only teacher has said, find the value of n after that. So what was the equation again? N squared minus what? Minus 2n minus 4 is equal to what? 479. Then you can see, guys, this is a quadratic equation. It's just that we're not solving for x, but we are solving for who? For n. Make sense? You see? Duo moi is like, no, doesn't make sense. Okay. Duo moi. How long have you been in the live? Have you just joined in? Because like if you're saying it doesn't make sense and you've just joined in, of course it's not gonna make sense. So you're going to have to pop up in my go to my YouTube channel there when I'm done. You know, the link is in my bio. You can check it out. Okay, n squared minus 2n minus 483 is equal to 0. Guys, this number here is too huge. So me personally, I would just go ahead and use the formula, the quadratic formula, and it works, guys. It works. Because some of you are going to try and find factors. You know what? Good luck. Okay. Yeah. Good luck. So me, I'd use the quadratic formula and just find the answer. So do the things that many people tend to know that they ought to do, but you will remember that you definitely make sure that when you do that, you don't. Yeah. Okay, but I love what Kamo says. So Kamo, they found the factors. Okay, so of course, 21 and 23. Okay, we know that the signs need to be different. And obviously, the biggest number will have the sign of the middle term, which is negative. So it's n minus 23 and n plus 21. And when you get the values, n is equal to, so we have n minus 23 is equal to 0, or n minus 21 is equal to 0. Final answer, n is equal to 23, or n is equal to negative 21. Sorry, suppose to say n plus 21, and then n is equal to negative 21. But we know that n cannot be a negative number, because have you ever seen people running in a race and then they say, and he came position negative 21, and then you have people screaming, yeah. Have you ever seen that before, guys? You have 21 racers and they are running, and then all of a sudden the announcer announces, look, coming in the negative 21 position, it is All Songs. Have you seen such, guys? Like, I mean, really and truly, like, if ever that is the situation, then we know something is completely bonkers. Someone has definitely lost their marbles. So that's why we reject the negative position, because it does not exist. Such does not exist. So it must mean that this term here, 479, it's a value of a term that is occupying the 23rd position. So you can say n is equal to 23, and T23 is equal to 479. In my estimation, that is very much true. Which term, this was the question, which term in the sequence is equal to 479? Please take note the difference between this question. The question here was saying calculate the 35th term. If they're saying the 35th term, it means this is the position. Substitute the position in the place of n, solve, and get the value. This is the value of the term. This one is saying which term, meaning what is the position of this value 479. So that means you equate Tn with 479. You substitute Tn, which is n squared minus 2n minus 4. That is the formula. You equate to 479. You use your understanding of solving quadratic equations, and solve them by factorization if you want, or you could use the quadratic formula. But don't forget, if you use the quadratic formula, guys, then the formula needs to be tweaked. N is equal to minus b plus minus b squared minus 4ac over 2a. But why is this guy now using n? Remember, guys, we are solving for n, therefore the x needs to be changed to n. Okay, please. Otherwise, if you don't do such, Chisambama. Okay, and I don't think you guys want Chisambama. I don't think so. All right. So here's your challenge question. You guys can do this question here. Let's see first. Let me just check, so that may go sleep, please, bro. I'm off. Oh man, people are making me laugh in the comment section. At least people are keeping me laughing. I appreciate you guys keeping me laughing. I really, really, really appreciate it. Okay, yeah. Now, surely there's other questions where quadratic number patterns are concerned. Okay. Okay, let's go to KZN. Here the first three terms of a quadratic sequence are given 3, 8, 15. Question number 1. Determine the general term Tn of the sequence for 4 marks. And then the second question is 1700 a term in the sequence. Motivate your answer using calculations for 4 marks. So let's go. Let's try this one out. We are in KZN. Woo! Welcome to KZN. Any KZN people that are listening here in my live right now, please comment very crazily in the comment section. If you are from KZN, you are here. This was in the trial paper for you guys in the past year, or maybe the year before, I believe. So that is the question. The first three terms of a quadratic sequence are given 3, 8, 15. Question is determine the general term of the sequence, the first one, and is 1700 a term in the sequence. Motivate your answer using calculations. Okay, let's go. Any color? Yeah, guys, some people are still having the time of their life here, like, surrounding areas. Can you hear the music playing in the background? Can you? All songs, you're really welcome. You know, Moss. Yes, all songs. Please do it. I want you to do it. I am not going to do it. I did an example for you guys. Now I want you guys to exercise your man skills and your woman skills and your whatever other skills that are maths related, and bust them out and show me what you got. You're welcome, Livia. You're welcome. You guys are welcome, as you know, most. Welcome. Thank you so much as well for being around, for joining in the sessions and having the time of your life in here, giving me the time of day. I mean, even the time of morning. Yeah. I think even Dark Sonic is very appreciative, guys. Like, yeah, he's like so ecstatic right now. He cannot contain his joy. Simply overjoyed. He wants to join in the fun, like totally, completely. So after you're done with this one, I'm gonna give you another one. We're gonna move from KZN and go to the Free State. Just let me know in the comment section the minute you guys are done with 2.1.1 and 2.1.2. All right, and then you never mind 2.2 for now. Okay, unless you want to give it a crack for your own, just for your own enrichment. Okay, it has nothing to do with the quadratic number pattern we are focusing on right now. But I do want us to at least do this, the 2.1.1, 2.1.2. Then I want to move to the Free State, okay, and then to Limpopo province, okay. so that you guys can explore the other questions that were asked in the other provinces. Okay, it seems like no one is from KZN here, because no one commented in the comment section when I said, all the people in KZN, give it up. Or was it Spinara? Spinara is from KZN. Yeah, okay, maybe Spinara is from KZN. Maybe the yes was from Spinara, is indicating it's from KZN. Oh, from Gauteng. All right, okay. All right. Gauteng. General term happening, guys. We got the general term for 2.1.1. Oh, look at Samantha. Samantha got it. Samantha, could you type it in the comment section? What's the general term that you got? You guys can go ahead and do that, just so that we can see if there is some common elements in the answers that you got, or what. Right. Sure. That's insane. 90 minutes. Crazy. Gone live. 90 people, 90 minutes. It's crazy because I'm so curious to know how many people are probably sleeping on this live. Like, I can just see someone, they were listening so attentively, but then gone. Rockabye baby on the treetop. So good night, good night. Type deal. Gang, gang. Olivia. Samantha. Any general term stated? And 2.1.2, when they say is 1700 a term in the sequence, motivate your answer. Remember, for that, I hope you guys see what it is that you need to be doing if they are saying is 1700 a term in the sequence. Okay. Okay, should I turn my attention to the other problem, or are we still writing? 2.1.1 and 2.1.2, can I go to another to be done, or are we still busy here? So can I change? Where did I say would go next? Welcome to the free state. Welcome to the free state. Okay, guys. Wow. Was that alive or was that alive? That was a live and a half, don't you think? Guys, I'm really gonna have to call it quits here, if you guys don't mind, because yeah, I am having a bit of an early morning as well today, so Yeah, I think this is as far as I can push it. I know some of you may probably be feeling like, no, why don't we stay a bit longer? But I have to unfortunately pull the plug here on the baby. Hopefully you've screenshotted this. You've actually done it as well. Your TN is TNing. Okay. I don't know how many of you were able to get the first term of this sequence, because you are given not 7 and 12 as the third, fourth, and fifth terms. We did it. We did. Yeah, and hopefully, guys, you must allow this to help you build like your own personal momentum. I think if you guys need, I know like there's a lot of resources online. There's apps for days, man. There's many things to work, to use as resources to work. So please practice. When you have time, especially those who are writing this year, please practice. Yeah, don't allow a day to actually pass by when you don't go above and beyond. The more you go above and beyond and you actually master the concepts through practice, the more solid you'll be in the maths. And the easier you will be able to see certain things, and the easier it will be for those things to have a longer shelf life. Quickest way to make sure you don't forget a lot of things is to ensure that you practice. But if you want to quickly forget, I don't care how you could have the best teacher in the world, and the teacher can teach you so well and you can feel good. But if you're not doing your part, and if you're not pulling like some serious stops for yourself, then you'll find that your efforts are kind of like in vain. So please, guys, let's do the most. Otherwise, I believe in all of you. Thank you so much for joining in again. Yeah, it seems like you guys are really, I can see how hungry a lot of you are where this is concerned. And I'm glad that I can share the journey with you, that I can be your host as well, and that you guys are also like just showing up and doing your part. Thank you to everyone that's participated. So yeah, I'm gonna love and leave you. We'll do the corrections of this tomorrow, definitely. Well, actually, today, later on, today at night, we'll do the corrections of all of this work so that you guys can see how things, some of the other questions are done. But unfortunately, I won't be doing those now because, like I said, guys, I had to hit the sack. Right. Thank you so much again. Thank you, all songs. Yeah, they are. That's what I was saying to you, Samantha. But thank you so much. And the all songs, thank you, brah. You've been a sport winner. You have been the man of the match. We call you the man of the match, the man of the moment. Thank you so much. We'll see you obviously then on Friday, and work very well. Enjoy work. Just enjoy yourself and have a productive time at work. Let's call it all a morning. No, definitely, Livia. Thank you so much as well. You've been a sport. Lady of the cloth, the one who uses parenthesis to basically articulate maths concepts. Thank you so much as well. You've been a great sport. Samantha, amazing. Thank you so much. You're phenomenal, and thank you for giving all songs some time in the sun here. Is doing the most, this guy. We'll definitely enjoy the week, and we'll try and enjoy it, even though you won't be around. Also, it won't be the same. Definitely, you've basically solidified your place in these lives. I think, guys, without further ado, let me end this live and let us go forth. Good night, and it was a good time. Let's see if I can't just let's see. I just want to see here. Samantha, you've been amazing. All songs lyrics, Livia, thank you so much. Star Christy, Spinara, Keke, Just Luvo It's Beauty, Eric Mukari. Okay, just those people that have been very active and very participative. I see some I hear Liang Ngola, Zaiz Jan, Tumi, James, Joski, Jacques Buchman, Liambo, Mlamleli, Sboniso Kenzo Nari, Core, The Unknown, yeah, and many others. Alright, guys, night. See you again. Good night.